여러분 안녕하세요.
Hello
제7차
everyone.
방사성 폐기물
I'm
안전관리
MC for the
국제
7th International
심포지엄의
Symposium
진행을
on Safe
맡은
Management of
김민희입니다.
Radioactive Waste.
정말
My name
온라인으로
is
많은
Minnie Kim.
분들이 함께 접속하고
And we have
계시고
a lot of people
현재
joining the
방사성
symposium
폐기물 안전관리
online.
국제 심포지엄이
And
7회를 맞이한
marking
가운데
the 7th of
가장 색다르게
symposium,
그리고
I think
가장
we are
많은
having
분들의
this year
노력으로
very
결실을
different
맺는
manner,
자리가 오늘이 아닌가
maybe
싶을
showing
정도로
our
뜨거운
outcome of
열정과
our
동시에
efforts
변화를
and with
모색하는
the great
자리입니다.
encouragement supports
정부의
we are gathered here
사회적인 거리두기
today.
격상에 따라서
And
현재
following
완전히
the
온라인으로
enhanced
진행을 하고 있고요.
social distancing
유튜브로 함께하고
measures
계신
from
온라인
the government, we are
참가자분들께
having this
환영의 인사
symposium
말씀을
fully
유리방
online,
너머로
and I'd like
그리고
to
화면
extend my
너머로
warm
인사드릴
welcome
수밖에
to
없음을
everyone joining
송구한
the
바 전하고
YouTube.
싶습니다.
And I'd
현재
like to ask for
접속하고
your
계신 분들
understanding,
그리고 아직까지
okay, for
접속을
those
못하신
already
분들께는
connected
얼른
and
접속을
also
하시라고
for
좀
those
소개를
who are
해주셔야 될 것
waiting.
같은데
I think we
오늘
need
행사
to wait,
사전 등록을
and
통해
I have an
참석하신
announcement to make.
많은 분들 가운데 개인별 발급받으신 등록번호,
If you registered for
유튜브
the symposium in
참가
advance,
인증,
please
화면
send your
캡처,
registration
사진,
number,
그리고
YouTube
상품
screen capture, and the
수령하실
address to
주소까지
receive
여기 지금
our
주소
gift
나가죠.
to this
세크레테리앳
address on the
골뱅이
screen.
2020
Secretariat at
사람.com 이리로
2020
보내주시면
SaRaM.com.
선착순 200분께
Gifts
선물을
will be
드려요.
sent to 200
선착순
people
200명에게
on a
선물
first come
드리니까
first served
지금
basis.
접속 아직 안
Once
하셨으면
again, it will be
얼른 좀
only 200
접속하셔서
people, so if you are
빨리빨리
not
자리
connected yet,
3종 세트
hurry up
보내시라고
so that you
말씀드리고
can
싶습니다.
get our
선착순
gift.
200분 안에
Alright,
여러분의
once
주식을
again, gift
응원하면서
will be sent to
시간
200
인사문을
people.
한번 열어볼까 합니다.
Good luck to you.
행사 시작 전에
Alright, before
여러분
we
알고
begin,
계시겠지만
maybe
라이브
you already
채팅에서
know,
진행이 된 퀴즈에
in the live
많이
chat room,
참여하셨나요?
there
알고
were
참여
quiz,
못하신 분들
and I
다행히
hope many
아직
people
기회는 남아있습니다.
participated.
사이사이 함께 하실
If you
시간들이
didn't,
좀 있는데요.
don't worry, we
퀴즈
still
이벤트
have more
진행은
quiz to
계속해서
come,
중간에
so
브레이크 타임
don't miss them.
이용해서
During the break
진행될 거니까
time of the
브레이크
symposium, we
타임에서도
will have a
긴장
quick
놓치지
quiz
마시고
event, so
여러분에게 선물에
don't miss it,
주시기
and
바랍니다.
you will be the one winning
오늘
our
함께하는
gift.
제7차
Alright, the
방사성
7th
폐기물
SaRaM
안전관리
Symposium
국제
for safe
심포지엄은
management of
지금
radioactive
함께하고 있는
waste
개회식을
management.
시작으로 해서 공모전의
We'll start with
결과
the opening
발표를
ceremony,
이어가고
followed by
결과
idea
발표의
contest and
발언이어
award
시상식이
ceremony. Then we will
진행됩니다. 그리고 나면 본격적으로
Then we
오늘
will
우리가 함께 나눠야 될
have
이야기죠.
presentations focusing on the topic of the symposium, the current status and future of the road waste management by invited foreign speakers. We have long hours, but it will be a very meaningful and fruitful time. All right, then let us start the 7th SaRaM Symposium with encouraging video messages from citizens.
2020년 코로나
국내의 안전하고 발전적인 미래를
방사선 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 포라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사능 폐기물 안전관리 국제 심포지엄 개최를 축하드립니다. 이가, 안전, 환경 모두 다 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다.
앞으로도 미래 세대를 위해 힘써주세요. 화이팅!
화이팅!
방사선 폐기물 안전관리 심포지엄 화이팅!
제7차 방사선 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사선 폐기물 안전관리 심포지엄에서 방사선 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사선 폐기물의 안전한 관리를 위해 항상 힘써 주셔서 감사합니다. 한국원자력환경공단 응원합니다.
국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사선 폐기물 안전관리 국제 심포지엄 화이팅!
제7차 방사선 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
안전한 날만 스타트해주세요. 또요.
코로나 속에서도
화이팅!
화이팅!
Yes, we just watched many encouraging messages from the citizens. They showed their perception and understanding on the road waste management. So I think it gives a great boost for the successful opening of the symposium. And it gives me a great, a boost and energy. So I think you share the same feeling. All right, the temporary storage facility for spent nuclear fuel in Korea is expected to reach a saturation point in the near future. Maybe you already heard that. So it is more important that we are gathered here today at the 7th SaRaM Symposium. We are going to today share high-level road waste technology development status and direction at home and from abroad. That will be the first we are going to do, and then together we will look for solutions to ensure safety of high-level waste storage and disposal. So, to give a great support, we have a welcoming opening, congratulatory remarks. We have presentations ready. So, I hope all of you to stay till the end of the symposium. All right, then, before we have opening and welcoming remarks, let us watch a video clip for the symposium.
대한민국의 에너지를
The
책임지고
Republic
있는
of Korea's
원자력.
energy is led by the nuclear
원자력 에너지
energy.
이용 과정에서 발생하는
Radioactive wastes
방사성 폐기물
generated
안정성에
during
대한
the
불안과
atomic energy
갈등은
have made
계속되고
people
있습니다.
feel anxiety about
방사성 폐기물
stability
관리에 대한
and cost
인식이
conflict which are still ongoing.
우려스러운 우려를 또 할 수
The Ministry of Industry, Commerce and
신뢰받는
Energy's
안전한
nation related to
처분 시설,
radioactive
건강하고
waste
깨끗한
is good
미래를
concern.
만들기 위한 노력은
Reliable and safe
선택이 아닌
disposal
필수가
facility.
되었습니다.
The effort to create sound and clean future is not an option but a must.
원전 수입국에서
Successfully
원전
turning from a nuclear
자리매김하며
power plant importer
세계
to
최고의
exporter,
원전
the
기술을 자랑하고
ROK
있는
takes
대한민국.
pride in having the world's best nuclear
인정받고
power
있는
plant
우수한
technology.
기술과 안정성이
Behind the recognized excellent technology and stability lies the safe management of radiation from the nuclear wastes.
책임 있는 방사성 폐기물
To
관리를
ensure
위해
responsible
중저준위
management
방사성
of
폐기물을
radiation,
안전하게
we
처분할
have safe
처분
disposal
시설과
facility for low
안전한
intermediate
운송을
level
위한
waste,
방사성
and to
폐기물
ensure
해상
safe
운반 전용
transport,
선박 등
we have
관리 기반을
designated ships
갖추었습니다.
exclusive for radioactive waste.
또한
As
인수,
such, we have
운반,
basis for
저장,
management, also
처분을
from
하는 전
takeover,
과정은
transport, storage to
엄격한
disposal.
기준과
Strict
안전한 설비를
standards,
통해
safety
이루어지고
design
있으며
are applied
치밀한
in this
원격 추적
whole
관리로
process,
안전성을
and
높이고
thorough
있습니다.
remote tracing contributes to the enhancement of safety.
대한민국은 지금
The Republic
국민의
of
안전을
Korea
최우선으로
is
하는
now facing
안전하고
an
깨끗한
energy
에너지 전환
transition
시대를
era
맞이하고
towards a
있습니다.
safer and cleaner energy, putting
국가 에너지
public
정책
safety
패러다임을
first.
전환하는
During the
과정에서의
energy paradigm
최우선
shift of the
과제는
country, the top
사용 후
priority
핵연료
task
관리,
is the spent nuclear fuel management.
즉 고준위
The
방사성 폐기물
creation
관리
of
사업의
basis for
기반
management
조성과
of high-level
처분 기술의
radioactive
개발은
wastes and
한국
disposal
원자력
technology
환경공단의
development
중요한
are now
과제가 되었습니다.
important tasks for CORAD.
최고의 안전성으로
With the best
신뢰받기 위해
safety,
노력하고 있는 한국 원자력
CORAD is
환경공단
making efforts to earn
에너지
the
전환
trust.
시대를
With a
한
mission
발
to
앞서
move
나간다는
ahead
사명감을
of
가지고
energy transition
방사성
era,
폐기물의
CORAD will
안전하고
safely
효율적인
and
관리를 통해
efficiently
국민
manage
생활의
the
안전과
radioactive
환경을
wastes
지켜나갈
to ensure
것입니다.
safety in people's lives
지속적인
and
기술
protect the
개발을 통해
environment.
안전한
Their
관리에
continuous
필요한
technological
추진 기반
development
구축과
will lay
핵심
the
기술을
groundwork
확보하고
for the
신뢰할 수
implementation
있는
needed for
관리
safe
정책을
management
실현시키기
and
위해
secure core
노력하겠습니다.
technology and to realize reliable
다음
management
세대를
policy
위한
will make
깨끗한 환경,
efforts. Safe
행복한
environment for the next generation, happy
안전으로
future
신뢰받는
will be
국민의
shaped
코라드,
by CORAD,
한국 원자력
trustful
환경공단이
agency
만들어갑니다.
to the public.
Okay, through the video clips, it covered what we are going to cover at the symposium. Following the video clip, now we will have distinguished guests to deliver opening and congratulatory remarks. First, from the CEO of CORAD, Cha Sang-soo, will deliver opening and welcoming remarks.
안녕하십니까?
Hello, everyone.
한국원자력환경공단 이사장
I'm Song
차성수입니다.
Soo-cha, CEO of CORAD,
제7차
Korea Radioactive Waste
방사성
Agency.
폐기물 안전관리 국제
I
심포지엄에
wholeheartedly welcome
참석해
everyone
주신
to the 7th
많은
International
분들을
Symposium on Safety
진심으로
Improvement and
환영합니다.
Stakeholder Confidence in
우리
Radioactive Waste
공단에서
Management.
추진하고 있는 방사성 폐기물 관리
For
사업은
radioactive waste
다양한
management projects conducted
이해관계자와의
by CORED,
지속적인
it is
소통이
essential for us
필수적입니다.
to continuously communicate with
이를
various
위해
stakeholders. For this
2014년부터
reason, since
국내외
2014,
전문가가
CORED
한자리에 모여
has hosted
방사성
this
폐기물의
conference, inviting
안전한
experts
관리를 위해
both at home
각국의
and from
경험을
abroad
공유하고
in order to share
논의하는
and discuss
자리를
experience
마련해
of each
왔습니다.
nation for safe management of
이번
radioactive
심포지움은
waste. At this year's
안타깝게도
symposium,
현장의 한자리는
unfortunately,
아니지만
we are not gathered together in a
온라인상의
conference hall.
한
However,
공간에서라도
we have organized an
함께
online venue
각국의 경험을
where we can share
공유하고
and discuss
논의하는 자리를
experience from each nation.
마련했습니다. 온라인 운영을 통해
I sincerely
더욱
hope
많은
that by holding the conference
일반
online, it will be a
시민분들이
more meaningful
각자의
opportunity,
자리에서
providing
손쉽게 참여할 수
broader
있어
and easier access
더욱
to
의미
a
있는
higher number of
심포지움이
stakeholders and the
되기를
general public to
바랍니다.
join the symposium.
이번 제7차
At the
방사성
7th
폐기물
International
안전관리
Symposium on
국제
Safety
심포지움에서는
Improvement and Stakeholder
해외
Confidence in
고준위
Radioactive
방사성
Waste
폐기물
Management,
기술
we will
개발
have a
방향과
fruitful time sharing
각국의
technology
경험을
development
공유하는
directions of high-level
유익한
waste
시간이
management
될
abroad,
것입니다.
as well as experience in each
추가 배경에
nation.
대한 부연 설명은
Let me explain
자리를
more in
옮겨서
detail about the background in a
진행하겠습니다.
different setup.
저희 한국 원자력
A Korea
환경공단에서는
Radioactive Waste Agency
방사성
hosts
폐기물
the
안전관리
International
국제
Symposium on
심포지움에
Safe Radioactive
개최하고
Waste
있습니다.
Management every year.
올해는
And this year,
축제를 맞이하게 됩니다.
we marked the 7th of SaRaM Symposium.
제1차 심포지움에서는
At the first symposium,
해외 전문가들이
together with foreign
다음
experts,
해에 맞이할
we
건물
made
처분
preparations
시설의
for operation of a
준비하면서
cabin disposal facility
토론을
planned for the following
통해
year. And
기술적
based on the
안전성에
various
대한
discussions,
객관적인 확인을
we identified and
하면서
confirmed the technical
시설의
objectivity
적기 운영의
and timely
가능성을
operation of the
확인하여
disposal
주었습니다.
facility.
2차 국제
At the
심포지움에서는
second international symposium,
방사성 폐기물이 중저준위 처분장이
as
마련되어
a low and
운영이
intermediate
시작되어서
level waste
다음번
disposal facility
과제인
became available and started
사용 해결료에
operation,
대한
we discussed the
토론을
subsequent
하였고
topic of a spent nuclear
해외
fuel.
전문가들의 경주 선언문을
And
통하여
based on Gyeongju Declaration
사용 후
by foreign
해결료
experts,
안전관리
we
원칙을
clearly defined the principles for
설명하였습니다.
safety management of a spent nuclear fuel.
제3차 심포지움에서는
At the third symposium,
고준위 방사성 폐기물의
we
관리에 대한
identified and confirmed that the needs of the future generation on high-level radioactive waste management were in line with the government policy directions.
제4차
At the
심포지움에서는
fourth symposium,
국제기구 전문가들과
we
국내
organized
대학생들
a
간의
talk concert,
토크 콘서트를
an opportunity
개최하였습니다.
for discussions where experts from international
토론회를
organizations
통해서
communicated with
미래
university
세대
students in
참여를
Korea.
통하여 지속 가능한
At these
방패물
discussions,
관리
with the
사업
participation of the future
구현의
generation, we confirmed the
확인하였습니다.
need to realize projects for sustainable road waste
제5차
management.
국제
At the
심포지움에서는
fifth symposium,
협력업체,
subcontractors
시민 참여
and
협동단이
Citizen
함께하면서
Participation Innovation Group joined
방패물
together,
관리 사업의
and
상생
we had an
방향을
opportunity to
논의하는
discuss win-win
자리를
solutions
가졌습니다.
for red waste management act
6차
projects.
심포지움에서는
At the sixth
국내
symposium,
주요 정책을
we discussed the
토론하면서
main policies in Korea
국내 방패물 관리
and
사업의
future directions of
방향을
domestic
논의하였습니다.
radioactive waste management policies.
보신 바와 같이
As I just
그동안
showed you,
개최한 국제
at the international
심포지움에서는
symposiums hosted so far,
한자리에
we have
모여
provided
방사성
opportunities for
폐기물
local and
안전
foreign experts
관리를 위해
to gather
각국의
together
경험을
and
공유하고
share and discuss
논의하는
each nation's
자리를
experience in
마련해왔습니다.
safe radioactive waste management.
드디어 2020년
And
올해
here we are
7회를
today in
맞이하였습니다.
2020, the seventh
2020년은
symposium.
우리 모두에게
Year 2020
어려운 한
has been a
해였습니다.
very difficult time to all of us.
명절
On
때면
holidays,
할머니 할아버지 댁에 가서
we used to visit our grandparents
상쾌한 공기도 마시면서
and enjoy
나가서
outdoor
야외
activities,
경험도
and
하고 맛있는 것도
we
먹고
also
이러한 것들이
enjoyed
우리에게
delicious foods.
일상이었는데
These were our daily normal life.
흔한 일생이 모두
But
바뀌어버렸습니다.
all our ordinary daily life has now changed.
코로나 19 때문이죠.
That's because of COVID-19 pandemic.
심포지엄 역시 개최 여부에 대해서
We
많은
also
고심을
had a lot of
하였습니다.
concerns and put great thoughts in
대한민국의
hosting the
방역 지침에
symposium.
따라
In consideration of the
심포지엄
quarantine
개최
guidelines of the
방법에
Republic of
대해서
Korea,
많은
we had a
고민과
lot of
토론하였고
concerns and discussions
결론은
on how to organize this
코로나19에
year's
맞서
symposium,
대응하기
and
위해
we decided to
사회적
host the
거리두기
symposium
2단계
online
방역 지침에 따라
following quarantine
온라인으로
guidelines and
개최하기로
measures
하였습니다.
for level 2 social distancing in order to fight against
2020년은
COVID-19. Year
코로나
2020
위기를
has
맞이했습니다.
encountered a crisis
그렇다고
due to COVID-19, but
2021년에
in 2021,
마스크를 벗고 예전과 같은 생활로
can we
돌아갈 수
really take
있을까요?
off our face mask and go back
쉽지
as
않을
we
것
were
같습니다.
before? I think it will not be easy.
앞으로 어떤 위기가 닥쳐올지 모르는데
We don't know what kind of
그렇게만
crisis
해서는
is waiting for
안
us in the
된다고
future,
생각했습니다.
so we thought we cannot just
우리는
try
이미
to avoid or hide all the
조금씩
time.
코로나19를 어떻게
We
극복해야
are already
하는지
learning little by little
알아가고
how to
있습니다.
overcome COVID-19.
지금처럼 확진자가 심할
At a time
때에는
like this,
대면
with an
활동을
increasing number of
줄이고
positive cases,
비대면으로
we need to
소통해야
reduce
한다는 것.
face-to-face activities and
이번
try to have a
심포지엄 또한
non-face-to-face communications.
당초에는
This year's
온오프라인
symposium was
병행해서
initially planned to be held
전면
both online and
온라인으로 추진하는
offline,
것처럼
but we decided to have it fully online.
유연한 자세가 우리에게
I
필요한
believe this kind of
시대인 것 같습니다.
flexibility is required at this moment.
방패물 관리를 하고 있는 저희 원자력
At
환경공단에서
CORED, which is in charge of
2021년
radioactive waste
화두이자
management,
난제는
the key topic and
바로
serious challenge in
고준위
2021 is high-level
우리에게
radioactive
항상 어려운
waste.
숙제
In order
고준위
to
방패물에
find a
대한
solution for
해법을
this
찾기 위해
everlasting
지금도
difficult challenge,
공단은
CORED
열심히
is making
노력하고
efforts
있습니다.
even at this moment.
2020년
Well,
정말 반가운 소식이 한
there is
가지
one good
있다면
news in 2020
2021년부터
that's
대한민국 정부
starting from
3개부터 주도로
2021, led by 3 government agencies of Korea,
저장 처분 안전성
we will
확보를
embark
위한
on a core technology
기술
development
개발
project, which is to ensure
시작한다는
safety of
겁니다.
spent fuel storage and
3개
disposal.
부처가 함께한다면
With the collaboration of the
그동안
3 government
해결하지 못했던
agencies,
어려운 실타래를
I hope it will
하나씩
be a good
풀어가는
opportunity
계기가
to
되지
solve this
않을까
difficult challenge
기대해
step by step.
이렇게 대한민국 정부 주도로
For the
추진되는
project
사업을
led by
위해
the Korean government,
국내 유일한 방패물 관리 전담 기관인
CORED, the sole radioactive waste management
함께
organization in
고준위
Korea, has
방패물
organized this
관리
symposium
미래 기술의 현재와
in order
미래에
to
대해
discuss current status
고민하기
and
위해
future
이
of
자리를
advanced technologies for
만들었습니다.
high-level radioactive waste management.
국내 현황은 어떠한지
For current
기대
status in
현황은
Korea
어떠한지,
and in other countries, to which
앞으로 고준위 방패물의
direction
관리의 미래가
the future
어떠한
of high-level
방향으로
rad waste management should
추진되었으면
move
하는지
forward,
여러분의 소중한
I'd like to ask for
관심과
your
의견
valuable
또한
opinions and
부탁드립니다.
interest.
방사성 폐기물을 다루는
Well, experts
전문가분들은
who handle the radioactive
방패물
waste
기술
are
개발이라는 단어가 익숙하지만
familiar with the term
아마
radioactive
일반 국민
waste
여러분께는
technology development,
너무
but I
어려운
guess
단어일
it
것
sounds too
같습니다.
difficult to the general public.
모두가 대답하고 공감할 수
So
있는
I'd like to tell a
이야기를
story
한번
which can be
해보려고
answered
합니다.
and shared by everyone.
여기에 노란색인
Here is a
듯
square
황토색인
in
듯한
yellow, or is it
네모가 하나
reddish
있습니다.
brown?
이게 무엇일까요?
What is this?
공단의 홈페이지를
If you
방문해
have
보신
visited our
적이
website
있으시거나 방송에서
or
접해보신
seen it on
분들은
TV,
바로 방패물
you probably
드럼이라고
thought that that's
생각했을 것
radioactive
같은데요.
waste drum.
하지만 정답은
But the correct answer
통합
is
차량입니다.
school bus.
보시는 바와 같이
As you can see,
방패물 드럼은
the
우리
rad
미래의
waste drum
세대가
has the
안전한
same
근황로를
color
위해 타고 다니는
as the vehicle which
차량색과
safely transports
같습니다.
our future generation to school.
제가 여러분께 드리고 싶은 말은
What I'd like to tell you here
공단에서는
is that at
방패물
CORED,
드럼을
we
안전하게
are
관리하여
continuously putting
우리
effort
미래
to
세대에게
ensure
깨끗하고
clean
안전한
and safe
미래를
future for
보장하기
our
위해
future generation
끊임없이 노력하고
by safely
있다는
managing
것입니다.
radioactive waste
그럼
drums.
공단에서는
Then
어떻게 깨끗하고
how are we
안전하게
going to
관리하겠다는
have
건지
safe and clean management?
공단의 현재와 미래가
How does the
어떤
present and
모습인지
future of a CORED
소개해
look?
드리겠습니다.
Let me explain.
저희 한국 원자력 환경공단은
Korea Radioactive Waste Agency, or
대한민국의
CORED,
유일한
is the one and
방사성
only
폐기물 관리
organization in
전담
charge of radioactive
2009년
waste management in
설립되어
Korea. We
올해
were established in
11년째를
2009 and
맞이하고
it's been
있습니다.
11 years.
저희 공단의 업무는
The main task of
방사성
CORED
폐기물
is
관리입니다.
management of radioactive waste.
우선 방사성 폐기물이
First,
무엇일까요?
What is radioactive waste?
방사성 폐기물이란
Radioactive
방사성
waste
물질
means
또는
radioactive
방사성 물질에
materials or
의해서 오염이 된
materials
물질로서
contaminated by
폐기,
radioactive materials
버려야
and
되는
therefore
대상이
are
되는
subject to
물질입니다.
disposal.
방패물은
Red wastes
원자력
are
발전소
generated from nuclear power
또는
plants
방사성
or
동위원소를 이용하는
hospitals,
병원, 연구기관,
research institutes,
산업체
and business
등에서
entities
발생합니다.
using radioactive isotope.
그러면
Then
방패물은 다
are
똑같을까요?
red wastes all same?
우리가 교육 과정에 따라서
As the education system is divided into elementary, middle, and high school,
방사성 폐기물도
red wastes are
방사능
divided
농도와
into
발생하는
low and
열을
intermediate level
기준으로
waste and
중저준위
high level
방사성
waste
폐기물과
according to
고준위
radioactive
방사성
concentration
폐기물로
and
구분을 합니다.
heat generation.
중저준위 방사성 폐기물과
Based
고준위
on the
방사성
low,
폐기물로
intermediate level
나누어
waste and high level waste,
저희 원자력
I will
환경공단의
introduce
현재와
the
미래에 대해
present and future of
소개해드리겠습니다.
CORAD.
먼저
First,
저희 공단에서 수행하고 있는
let me
중저준위
introduce the
방사성 폐기물
current status
관리의
of low and
현재에
intermediate level
대해
waste management at
소개해드리겠습니다.
CORAD.
공단에서는
At
중저준위
CORAD,
방사성 폐기물을 관리하기
in order
위해
to manage low and
처분
intermediate
시설을
level
운영
waste,
중에
we are
있습니다.
operating a disposal facility.
원전과 처분 시설은
Nuclear power plants and the
모두
disposal
해안가에
facility are
위치하고
all
있어서
located along the coastline.
각 원자력 발전소에서
At each nuclear power
방패물
plant,
드럼을
red waste drums
청정
are
누리호라는
transported
선박을
by a
이용해서
vessel named
처분
청정누리호
시설로 운반을
to
하게
the
됩니다.
disposal facility.
운반 후
The drums then
방패물 드럼이 처분에
are
적합한지
inspected to determine
아닌지 검사한
whether they are
후에
suitable for disposal or
본부 처분
not.
시설의 6개
And then
사이로로
they are disposed
처분되게
at
됩니다.
6 silos of a cabin disposal
경주
facility.
중저준위 처분 시설에는
At Gyeongju Low and
1단계
Intermediate Level Waste Disposal
동굴 처분
Facility,
시설을 운영 중에
we are
있습니다.
operating first phase cabin
그리고
disposal facility.
2단계 표충 접은 시설 건설을
And
위한 허가 심사가
License review is
진행되고
currently
있습니다.
in progress to construct the second phase surface
또한
disposal facility.
원전 해체 방패물의 반입을 위한
In addition,
3단계
we are
내리평
preparing to
처분
build a
시설의
third phase
건설을
disposal facility
준비하고
for rod
있습니다.
waste from decommissioning
이와
of
같이
nuclear power
저희
plants.
공단은
As
방패물
explained,
준위에
we
따라
have
처분
varied
방식을
disposal methods
관리하면서
according to rod waste
안전하게
levels
관리하기 위해
and
지속적으로
are continuously
노력하고
making
있습니다.
efforts for safe
이번에는
management.
중저준위
Now, let
방패물
me
관리의
introduce
미래에 대해
future of a low and
소개해드리겠습니다.
intermediate level waste management.
저희 공단에서는
At CORAD,
4차 산업혁명 시대에
in line
적합하게
with the fourth industrial
스마트한 처분
revolution,
시설로 변화하려고
we plan
합니다.
to transform into a smart
모바일 앱을
disposal
통해
facility.
방패물의
Using
정보,
mobile applications,
운반의
we will
경로
provide
등을 국민들에게
real-time information
실시간으로
on rod
공개하고
waste, transport routes,
방패물 검사
and
시스템을
others to the
완전
general
자동화하여
public. We will fully
직원의
automate a
피폭
rod waste inspection
검사
system
시간을
and as a result
단축하고
reduce
자율주행
exposal of
로봇이
our staff
처분 구조물의
and inspection
균열을
time.
감시하여
Autonomous robots will monitor
사이로의
fractures of the
안전을
disposal
확인하고
facility and ensure
처분 시설
safety of the
부지와
silos.
시설물
And
실시간 감시에
innovative
혁신
technologies will be
기술을
applied
도입하여
for real-time monitoring of the
자연재해 및
disposal site and facility.
산업재해를
And as a
예방하려고
result,
합니다.
we will prevent natural disasters and
4차
industrial
산업혁명
accidents.
기술 적용으로
By applying
앞으로
fourth
더
industrial revolution
똑똑해질
technologies, our
스마트
disposal
방패장을
facility will become smarter.
기대하셔도 좋습니다.
You may look forward to it.
그러면 다음으로
Now let me explain
고준위 방패물에 대한
the current
현재에
status
대해서
of high-level
말씀드리고자 합니다.
waste.
사용 후 해결료와 관련된 공론화가 진행된
Public discussions were held on spent nuclear fuel
공론화에 대해서
and its management,
재검토위원회를 구성하여
and a review
운영 중에
committee
있습니다.
was organized and in operation.
위원회 출범을 시작으로
Following the launch of the
올해
committee,
초에는 전문가
this year,
의견 수렴이
we have
완료되었고
completed collecting opinions from
10월까지는
experts.
전국 및
By
지역
October
의견
this
수렴이
year, we also
완료되었습니다.
collected the national and regional
시민
opinions.
참여형 공론 조사를 시행하였으며
We conducted a public
토론회,
opinion survey
미래세대
based on
워크숍,
citizen
공론
participation,
조사 등도
also had debates on TV,
시행하였습니다.
future generation workshops, and survey on
그럼
public
고준위
opinions.
방패물 관리의
Then,
미래는 어떨까요?
what is the future of
향후
high-level
재검토위원회
waste
공고안을
management
바탕으로
look like?
고준위
Based on the
방패물
recommendations
기본
from
계획을
the
보완할
review
예정입니다.
committee, we plan to enhance
기본
the
계획이
basic plan.
보완되면
Once the basic plan is
현재 포화에
revised,
다다른 고준위 방패물을
I believe it will be
저희
a new
공단이
starting point for
안전하게 관리할
CORAD
수
to
있는
safely manage
새로운
high-level
출발점이 될
waste,
것이라
which is close to
생각합니다.
reaching a saturation point.
오늘보다 더 나은
For a better,
내일에
for a future
공단을
better than
위해
today, and for better
계속해서
CORAD, we will
노력해
continue our efforts.
마지막으로
In
제7차
closing,
방사성 폐기물
I
안전관리
hope that the
국제
seventh
심포지엄이
symposium
모든 참석자
serves
여러분께
as a
의미 있는
very
시간이
meaningful
되시기
opportunity
바랍니다.
for all participants.
경청해 주셔서
Thank you for
감사합니다.
listening.
Well, he has talked about the past and the future. Even though it is a long journey, he said that we need to move forward. And also he conveyed a message of their support. Now we're going to invite the IAEA Director Christopher Zeri for the congratulatory remarks.
My name is Christophe Xeri, and I'm Director at the International Atomic Energy Agency. It's at the same time a pleasure and an honor to have the opportunity to make this statement today with you and to contribute to the opening of your conference. I would, of course, have been preferred to be physically with you, as I had the chance and the opportunity to do some years ago. This year is obviously not very possible to do that. And so I'm happy to still have the opportunity through this means to address you this morning. I think your conference, which is a yearly conference, is extremely important to give an overview of all the topics related to deep geological repository. Science is important. Technology and engineering is important, and with some programs in the world getting close to implementation, engineering takes now a more important role for those countries which are at that step. And of course, social factors are also important. In order to have a successful deep geological repository program, you need to have these three components: science and research, technology and engineering, and social sciences. And obviously, at each step, you need to have the right expert in each domain to work together and contribute. So I know that that's something that you are doing within this conference, and to have this broad perspective. I want to take this opportunity to underline the very good and lasting relationship between the IAEA and CORAD on this topic of deep geological repository, and the very useful and important role that CORAD has played to help and support the agency in moving fast in developing some reference documents, and not only useful for Korea, but useful for the whole world. Just to give some examples, we developed together the roadmap for a deep geological repository, and developed a compendium of the key scientific findings of the last 20 to 30 years of research, and developed associated structured training modules, work on stakeholders engagement, worked on siting, worked on cost estimation. So that's all the work the agency is doing, probably not all the work exactly, but an important part of the work the agency is doing in the field of deep geological repository. And on all those topics, we appreciate the support of CORAD and of Korea. I'm really wishing you a very fruitful conference and hope to have a chance to visit your countries as soon as possible.
Well, as mentioned by the director, we are going to share the current status and direction of each nation. Yes, thank you for the kind words. And we have one more congratulatory remark from the KEPCO International Nuclear Graduate School, President Nam Sung-an, by video message.
안녕하십니까. 한국
Hello,
국제원자력대학원
I'm Nam Sung-an, President of KEPCO International Nuclear Graduate School. I'd like to express my gratitude to CEO of CORAD, Song-Soo Cha, for organizing the symposium at this difficult time where every sector is not moving forward due to COVID-19. My thanks also goes to IAEA Director Mr. Christopher Zeri for joining the SaRaM Symposium online from abroad. And I thank all participants for joining the symposium with
참석자
great
모든
interest
분들께
despite the difficult
감사드립니다.
conditions due to strengthened
방패물
quarantine
관리는
measures for
어느 특정한
COVID-19.
국가가 단독으로 해결할 수 있는 문제가
Radioactive
아니고
waste
세계
management is not an
모든
issue
원자력
which can
발전
be solved
운영
by one
국가가
country.
같이
It's a
머리를
common
맞대고
challenge for
해결해야
which
될
all nations
문제입니다.
operating nuclear
오늘
power should put
개최되는
heads
방패물
together.
안전관리의
The
국제
SaRaM Symposium
심포지엄은
held today
이러한 방패물
is
안전관리를
an
위한
international forum based
해결책을
on
찾으려는
efforts from
각국의
each nation
공동의
looking for
노력으로 진행되는
solutions for
국제
safe
회의이고 모든이
radioactive
방패물
waste
관리의
management.
안전한 미래를 준비하고 있는 한국의
And for
입장에서
Korea, which is
방패물
preparing
관리
for safe future
선진국의
of
지식과
high-level
경험을
rod-based
공유할
management,
수
it
있는
will
중요한
be an
자리일
important venue to
것입니다.
share knowledge and
원자력
experience from
발전의
the leading
지속
nations
가능성을
in the
위해서는
field.
방패물 관리
For
문제에 대한
sustainable development
해결책이
of
나와야
nuclear
하고
power generation,
여기
we
계신
must
여러분들이
devise
그
solutions
지역이
for
되어야
rod-based
합니다.
management, and we should
여러분들이
take
이미
the
알고
leading role.
계시리라 생각합니다만
I believe you already
세계는
know
지금
that the
4차
world is
산업혁명의
now
거대한
entering
파도 속에
into
유례
an
없는
unprecedented
코로나
era of a
사태를
new
겪으며
normal,
한 번도
while
경험해보지
experiencing the great
못한
wave of the
새로운
fourth
뉴노멀 시대에
industrial
들어가고 있습니다.
revolution.
이러한 뉴노멀 시대에서
In this
방패물
time of a
관리의
new
접근
normal,
방법도
our approach
기존의
to
접근
rod waste
방법과는
management
다른
needs to have
새로운
a paradigm
패러다임이
shift,
필요하다고
moving away
생각합니다.
from the
이미
existing
다른
ones.
산업에서는
Other
디지털
industries are
기술과
already
융합한
developing
엑스포넨셜
exponential
기술들이
technologies
개발되고
converged
있습니다.
with digital
기존의 효율을
technology.
10 내지 20% 향상시키는
What we need is not
기술보다
technology with
10배,
10 or
20배를
20% better
향상시킬 수 있는
efficiency. We
엑스포넨셜
need
기술들이
exponential
필요합니다.
technologies which can
효율이
enhance
증가하면
efficiency by
당연히
10 times or
비용도
20
기하
times.
급수적으로 감소합니다.
With better
현재
efficiency, the cost will
원자력
naturally
산업계에서
drop
예상하는
exponentially.
기하
At
급수적으로
present,
증가하는
the nuclear
방패물
industry
관리 비용도
expects the cost for
방패물의
rod
관리
waste management
분야의
will increase
엑스포넨셜 기술들이
exponentially.
디지털
However,
기술과
if
융합되어
exponential technologies are
개발된다면
developed
모든
in this
국민이
field converged
걱정하는
with the
방패물
digital
관리도
technology, we can
저비용으로
find a solution
해결책을
at low
찾을 수
cost for
있을
rod waste
것입니다.
management, which
아직은
is a common
원자력
concern
산업계에서
of the
익숙하지
general
않은
public.
기술들인 디지털 기술들,
If we
특히
actively apply digital
AI나 3D
technologies which are
프린팅 등이
not yet familiar
원자력
in
산업계에
this
적극적으로
industry, in
도입된다면
particular if AI or
불가능하지는
3D
않을
printing are
것입니다.
applied, I believe
내년에
it is
개최되는
not
8차
impossible.
학회에서는
At the
이러한
8th
분야의
symposium
연구
to be held next year, I hope
결과들이
research
많이
outcomes in
소개되어
this area will be
전문가들
introduced
사이에서
and
많은 토론이
experts have
이루어져
fruitful discussions
방패물
on them
분야에서
so
국민적
that it
합의를
serves
얻을 수
as an
있는 계기가
opportunity to
되기를
generate
바랍니다.
public consensus
최근
on
가장
rod-based
핫한
management.
테슬라의 앨런 머스크는
A well-known business
자기의
leader,
한계를
Elon
미리
Musk,
정하지 말고
recommends
항상
that we
실현이
should not put a
가능하다고
limit on
생각하는
ourselves in advance and
목표보다
set a goal
훨씬 높은
which
목표를
is much higher than the
설정하라고
ones we
권고하고
believe
있습니다.
always
이러한
achievable.
그의 철학 덕분에
Thanks to
테슬라사는
his life
세계에서
philosophy,
가장
Tesla has
혁신적인
become the
기업이
most
되었고
innovative
이제는
business in the
전기자동차뿐
world.
아니라
And
인간
in
우주
addition to
시대를
electric
새로
vehicles,
개척하고 있는
today it is
스페이스X,
pioneering a space era for humanity with SpaceX and Hyperloop, which will take just 20 minutes from Seoul to Busan, running at 1,200 kilometers per hour. And as such, the company is introducing technologies literally changing the world. Technologies once thought impossible are commercialized one after another and are changing the world. I believe these accomplishments of Musk are outcomes of his philosophy on exponential technologies. I hope, like Elon Musk, you who study and research in the rod-based management sector become researchers developing exponential technologies which can change the impossible to possible in this field. Even directions many people think difficult or reckless, if we pioneer a new path by converging digital technologies, I believe we can change how we manage rod-based in Korea and in the world. King's is also nurturing human resources by providing education converged with AI to keep up with the fourth industrial revolution with great transformation. And they will lead the future of the nuclear power and rod-based management based on joint research activities among the industry, academia, and research institutes. King's will continue to develop both field and energy experts in the entire life cycle of nuclear power generation, including rod-based management, so that we can respond to changing government energy policies and rapidly evolving external environments, bringing synergy at a national level. Since the symposium today gathers the best experts both at home and abroad, I sincerely hope all participants have a fruitful time sharing a wide range of ideas and experience. I wish all of you good health and happiness. And once again, I thank members from CORAD for their effort in organizing the symposium. Thank you very much.
Well, thank you very much, President An Nam-sung. He supported the researchers and gave a very meaningful and valuable congratulatory remarks. Now we're going to have a session to announce the results of the contest of the radio waste management future technology idea contest and also awarding ceremony. Probably will this enhance the understanding and awareness of the public to this waste management. So we do have two areas of this contest, and there is the first one is from 2020 Courts Innovation and Social Value Project Discovery Contents has chosen 10 projects or new ideas were selected. Based on them, we had idea contest adding visibility, creativity, and topically. And also, we had the 30-second UCC contents based on Innovation Social Value Discovery Project. And we have chosen two best awards and the winner for this idea contest. And now we're going to also select the UCC's winners too. So we're going to play the video, pre-recorded video. There are ideas and contest, and also we're going to listen to the acceptance pages, and through that we believe that these will enhance understanding of the public toward this radioactive waste management importance. First, we're going to invite the three Futurism team and 서도영 and also Smart Alert System and Nimamu team with the drone and so on. And I'm going to announce two runner-up winners. The two teams are 박민지 team and 우리가 가요 team. Congratulations. Then first, we're going to invite the plan to handle radioactive waste to secure the security and transparency of the radioactive waste. I'm Park Min-ji. Our project is called Nuclear Energy and Blockchain Project. Safety first. For the sake of safe management of radioactive wastes with the blockchain technology for all the time, ensure continuous management of history and prevent leakage of waste is built first transparency, last transparency system. With these, we aim to safely manage radioactive wastes. Nuclear energy is needed at least for some decades to come. The energy is on the list of top 10 topics selected by Bill Gates, and particularly our nuclear power plants were sold to US and Europe for the first time in the world, and their safety was recognized. The local nuclear technology is one of the best in the world. Like semiconductors, we need more safety management. In the nuclear energy system, small and big accidents can happen, and the public believes that the unknown accidents are covered up. Why? Because people think that although nuclear energy agencies know the reasons, they don't fix them. This is because if someone volunteers to fix the fundamental problem, but if some unsavory incident happens to them, they will be no longer stay in the nuclear energy industry because the organizations are sensitive to safety issues. The key to the project is to open the history of management of radioactive wastes to the public on blockchain and reveal transparency to the public. That is why we need National Assembly and Resident Commission on Safety here to check history of the management. As all histories are on the blockchain, a detailed root cause analysis becomes feasible, and when an incident happens, this will not be neglected as far as it is on blockchain. And for this reason, we use blockchain. Blockchain is not visible. Conceptualizing it may be challenging. All history on the blockchain cannot be modified nor deleted. And you should remember this characteristic. If all records cannot be modified or deleted, the transparency of history will be imposed. As a result, public trust will improve and the number of safety accidents in nuclear power plants will decrease. This is imaginary webpage that I created. Via IoT, the waste starts to move, and I thought about keeping a record of this. When radioactive wastes are start off to move, we press IoT button, and when the wastes arrive in the site, then person in charge of informing of the incoming waste should press it to confirm. With this, we can get data telling from where to this waste moved and how long did it take and what time it was will be made known. I made this IoT, but we can add functionality on IoT features so that the storage while keeping the waste in it can sense the opening of the lid with a built-in sensor so that we can continue with the management of radioactive wastes in this way. And I thought that would be nice if I press the button, then on the screen the sign raise waste is on the move, and when it is delivered, the sentence is saying it is being delivered will be appealed later. If the person in charge of receiving does a signal and press the button saying arrived, the reporting on this, and if there's accident during delivery happens, then this can be organized in what I can create here. We use the IoT device called Raspberry, and we have set to update automatically every 1 minute. The screen shows the history received, and the content this will be displayed in the previous screen. I showed with legible text with this. We can trace radioactive waste movement, and if we place IoT onto the waste management box, we can trace history of radioactive waste management. If any of it is encrypted on blockchain, and if they are open to the public, then the public will not know the details clearly, but will understand that the record is being done transparently. If the National Assembly or Resident Commission that I mentioned earlier can see the history on the website, the credibility will enhance and transparency of information will be secured. In the end, this will improve public trust, and to secure public trust, I hope a huge progress in the future. Thank you. Well, that was a very nice and fresh idea, and I believe that is a very realistic idea that we can have that soon. Then let's invite her again to listen to her acceptance speech. I am Bang Min-ji. I am majoring advertisement promotion as well as in nuclear energy for master's thesis. I was writing about a plan for nuclear energy industry to be managed transparently by using public blockchain technology. I hope the related area to develop further to improve trust among public. Thank you for giving me the award. Well, she mentioned thank you for giving me the award. Well, thank you too for a great idea. Next, I'm going to invite other award winner. We're going to invite the 우리가요 team for their teen video, introduction video. Hi, we are Hong Young-min and Eun-young, who are participating in the contest for idea for future technology for radioactive waste management. We selected addressing radiation anxiety in the surroundings as the topic for this contest. We radiation map, radiation price list, shared radiation detector as our three ideas. The first idea, radiation map. As you can see from the screen, those shared skateboard and shared bicycles are used by placing radiation detector on them. So they can move across areas and measure the daily radiation dose from surrounding areas. This map is created by the voluntary movement of people. And this will be a map that will be created by detecting radiation around our living areas. We roughly counted the number of shared skateboards and shared bicycles and indicates the number on the map. Apart from those, there are many shared skateboards and bicycles are distributed, and one might easily find that those are distributed surrounding areas. So not only in our residential areas, but also those in other cities or in radioactive waste management facilities. These mobilities with radiation detectors will tell us the radiation amount and assure us in the places with high footfalls and address anxiety. For those areas where a few people visit, by distributing promotional coupons for those who would use them in order to encourage people to use them, thus would enable people to voluntarily update and through direct measurements by the local governments to update the map on a daily basis, and this is the idea. Our second idea is the price list for radiation. As of now, the MFDS investigate the radiation dose from the imported food to see and inform whether a certain level of dose is detected or not by making it more detailed. And through the price list, the markets, we can know the price of items like likewise, we can make a radiation dose list to see a total amount of the dose by giving an easy example to people by indicating the total dose of radiation coming from the food items that they purchase and compare the dose amount with the amount of dose they can get after being exposed per X-ray or per number on board. As such, creating the price list can relieve anxiety among the public on radiation. The third idea is a shared radiation detector detector. Due to fear of a radon, borough offices or local governments are lending the radiation detectors for the public. Like this kind of system for people who are living near the radioactive waste facilities and feeling anxiety, and for general public to address their anxiety about radiations, we need to offer a service to lend the radiation detectors for food, furniture, and surroundings. We may enable them to measure the amount of radiation and address their anxiety as well. Well, with this content, then our public can understand the movement and the disposal process of the safe radioactive waste management could be learned. And it was really nice. Then how about their feelings? Let's see their acceptance speech again. Hi, I am Hong Young-min, a winner of this prize from Radioactive Waste Management Idea Contest. Even though my teammate Agunyo could not participate in this opportunity due to personal issue, but so it's a bit sad. So we had a lot of discussion and share ideas for this idea contents and to prepare the PPTs and so on and other presentation materials via phone. And I believe that was a success factor. And I would like to thank the CORED for giving us such an opportunity.
Well, taking this really good opportunity, and I'd like to thank everyone for the contestants and everyone joining the contest for sharing their very insightful ideas. Now we have one last prize to go. That's a grand prize to award. I mean, we have already very interesting ideas. Now I'm very excited to reveal the prize that goes to Binhiji team. And the title is Changing Perception on Rad Waste. That's about the experience booth. Let us watch it together. Hello. We are one of the contestants participating in the Radioactive Waste Management to Future Technology Idea Contest. And our team name is Binhiji. And our topic is how to change the perception on rad waste with an experience booth. Based on what we learned about the rad waste management technologies, there were some experiences lacked among the general public, in particular in the regions near the rad waste management facilities. And as you can see on the screen in Gyeongju, there are protests from the residents to fight against the construction of a vector, which is to dispose of the rad waste. So we confirmed that with the experience booth and for better understanding, this kind of resistance can be further reduced. And obviously, the residents have a very negative implications or perceptions on rad waste based on the explosions and other external related worries. So, in order to eliminate such ill-founded worries, we try to come up with experience booth for the waste management. Such facilities do not additional constructions. It can be easily constructed because it's a kind of a easily movable experience booth. Have easy access in Gwacheon, Daejeon, and Busan, Gwangju. There are national science exhibition halls. Our plan is to have this kind of experience booth in these locations. And with the experience booth, this is how we are going to operate them. We have a one material with an LED, the gauge screen, so that the people can read the dosages of the radiation and putting them in the pool and concrete, and the readouts change accordingly. It seems quite simple, but visually it helps people to easily understand how the rad waste management works. And not just for the adults, it can also be used for educational purposes for little ones. So after experiencing how the rad waste are managed and treated like this, there will be another space to learn more about rad waste. So TV and other materials will show how radiations are emitted. And based on this, the prejudices and existing perceptions, negative perceptions may go down and will become more positive. However, due to the ongoing current pandemic, following the non-face-to-face activities, we also came up with how to communicate online. We have already existing platforms online. However, many people use YouTube, Facebook, and Instagram. If we utilize these platforms as well, we believe we can reach a wider number of people to enhance the perception on the road waste management, to eliminate further the negative perception on road waste management. This is another idea of ours to come up every week or every 2 weeks via SNS. We can generate a so-called based on card news. So based on the news provided, it's kind of word quiz so that they can fully understand, have a better understanding on the road waste management and related terms. And in addition to that, Instagram online quiz contest and uploading the video clips on the YouTube official channels. These are other communication channels that we can enhance the understanding of the general public. Thank you for listening. Well, it clearly showed the purpose of the contest. Yes, the idea itself, I believe, will certainly enhance the perception on the radioactive waste management of the general public, and everyone who now watched the idea, I think already changed their perception to a more positive manner. Let us hear the acceptance speech as well. Hello, I'm the winner of the grand prize of the contest in idea category. My team name is Binhiji. I am very delighted to be a great help to Korea and win the award of the contest. It may be a really small idea, but I think Korea paid a great attention to very in detail. That is the reason why maybe we could earn this grand prize. And I sincerely hope that our idea can really bring to positive perception on the road waste change. And I will continue to support you and put more interest as we move on. And I'd like to thank other colleagues for helping me creating this idea and the video clip. Thank you very much. Well, once again, congratulations to the Binhiji team. And I look forward to another good ideas from you as well. Yes, and now we will move on to another category, 30-second UCC contest. The 30-second UCC obviously have a limited time, so obviously we have, again, very interesting ideas. You may look forward to it. We have a participation awards, 3 teams, 오상훈 and 성은상. And Anytime to 2020 Nuclear Earth Safety Week. So these are 3 teams won the participation award for 32nd UCC, and we will take a moment to watch their video clips. And we have 2 teams for Excellence Awards. First goes to 이영희 and RMS team. Congratulations. And first, from 이영희, we will watch the UCC video titled Smells Sweet.
Hyper-focus my attention on you, baby. A selfish new dimension in my mind. You're exotic like a diamond. I can shake you. My sticky Aunt Jemima, sugar high. Ooh, la la. Can I get a pure injection of you? Ooh, la la. I just wanna drink you down. Ooh, la la. I'm telling you, I just can't live without you. I need you right now.
역시 30초 안에 모든
Well,
에너지를 다
yes, it
직결하면서도
shows a great energy,
간단하게
compact
이렇게 마음을
energy
쏙
in 30
스며드는
seconds and
메시지.
gives a
역시
really
30세
strong
MZ의 매력은
message.
이런 게 아닌가
That
싶어요.
is the, I mean,
수상한
the character
이용희님께
attractiveness of the
수상
30
소감 한번
second thesis.
들어볼게요.
Now we will listen to his
네,
acceptance
안녕하세요.
speech. Hello,
수상에 입상을 하게 된 이용희라고
I'm
합니다.
Yoongi Lee,
먼저 이상을
winner
주시게
of
된
the
원자력 환경공단에
Excellence
정말
Awards.
감사
First of all, I'd like
말씀드리고요.
to thank Coretta for
다른
giving me this
작품들
award.
제가 유튜브로
I checked
검색을
other,
해봤는데
contestants'
엄청
work
좋은
on
것들이 많더라고요.
YouTube. They
그래서
had a
상을
really
탈 줄
great works,
몰랐는데
and so I
또
didn't
상을
expect to
주셔서
win this
정말
award.
감사드립니다.
So I'm really delighted
다음에도
and
이런
thank you
행사가
very
있으면은
much.
또
And if there's another
더
opportunity like this, I will
입상할 수 있도록
certainly
노력하겠습니다.
participate to win another award. Once
감사드립니다.
again, thank you very much.
네, 저희도
All
다음에는 또
right.
어떤 작품으로
We
더
also will
말씀드릴지
look forward
기대해
to
주시면
another great work
감사하겠습니다.
from you.
그리고 RMSD
Okay,
팀
from
방대장
RMSD
안전을 드론이
team,
관리한다라는 내용인데요.
Drone
공식 영상으로
manages
지금부터 만나보겠습니다.
ROD waste management safety. Let us watch the
방사성
UCC
폐기물은 고준위
video.
폐기물과 중저준위 폐기물로 구분됩니다. 중저준위 폐기물은 기체, 액체, 고체로 나누어 처리하고 감시기를 통해 마지막 확인 작업을 실시합니다. 하지만 감시기는 오류 오작동의 가능성이 매우 높습니다. 감시기의 오류 오작동을 줄이기 위해 감시기와 드론을 결합시켜 실시간으로 감시기를 작동해 오류를 최소화시키고 사람의 접근이 힘든 곳까지 감시기를 작동시키게 하여 방패장 내부와 외부의 안전관리를 효율적으로 할 수 있습니다.
야, 드론이 움직이는 모습
Wow, how the
실감나게
drones
영상으로
move.
화면에
It was
보여줍니다.
quite
준비가
interesting to
쉬운데요.
see,
세
easy
분의
to
영상을
understand, all right?
만들어주신 우리
Creating
수상자
such an
소감
interesting,
들어보겠습니다.
the video clip, we will listen to acceptance speech as well.
안녕하십니까.
Hello,
네, 한국원자력환경공단 방패물관리 미리기술
I'm the winner of the
상을
Excellence
받게 된
Awards in the
팀의 대표 박상문이라고
in the contest for the radioactive waste
이번
management in future
공모전을
technologies. My name is
드론과
Park Sang-moon.
방패장에 관한 전문
At
지식을
the
많이
contest,
쌓을 수
it was a really
있는
good opportunity for me to
생각합니다.
learn and accumulate a
저와
really
이제
good
저희
knowledge on the
팀이
rod waste
이번에
management.
처음 공모전에
Me and my
출전하게
team,
되었는데
it was for us the first
이런
time to
수상을
join the
받을 수 있게
contest,
되어서
and
정말
winning this
매우
award,
기쁩니다.
we are really
그리고
delighted.
이제 저를 포함한
And I'd
저와
like to
함께한 팀원들과
thank my team
우상을
members
주신 이제 한국
and also to Karat for giving us this
감사의 말을 전합니다.
award.
네, 감사합니다.
Thank you very much.
재미있는 아이디어를
All right,
저에게
so with
보여주셔서
interesting
저희가 감사합니다.
idea,
수상소감까지
you
잘
are the one
들었습니다.
who we should
그럼
thank
이제
to.
대망의 추수상
All right,
발표를
we have
해야죠.
the
추수상을
grand prize to go
수상하신 이
now.
아이디어 보니까요.
I
실질적으로
watched a new
우리가
idea
바로 사용할 수
and
있는 아이디어다라는
it was
생각이
an
들었는데
idea we
어떤
can use
아이디어인지
it right
궁금하시죠?
away. So
자,
now you wonder
방소울림의
what it
방패물
is.
이동
Let us
현안조의
watch from
FCC
Bang Seoul
영상이 최우수상을 수상했는데요.
winning the grand
지금
prize.
그 영상을 함께
Let us watch
보시겠습니다.
the video together.
방사성 폐기물인 방패물들은 대체 어디로 가고 있을까? 택배 운송장 서비스처럼 쉽게 확인할 수 있는 방법은 없을까? 내 손안의 휴대폰 앱으로 방패물 이동 현황을 쉽게 확인하자. 방패물이 어느 선박에 이동 중인지와 현재 운반 현황, 현재 방사 능량까지 우리 사회에 꼭 필요한 혁신 기술 방패물 이동 현황 조회 앱.
네, 방패물의 이동
Well,
현황을 조회하고
how
바로
to
볼 수
track the
있으면
movement of a
좀
rod
막연하게
base,
두려웠던 그런 느낌이
if it's
사라지지
possible, I
않을까
think
싶어요.
it will greatly
곧볼
ease
수
our
있게 될
concern and
의미가 있는
anxiety. I think this will be launched pretty soon. I'm looking forward to it. Once again, congratulations. But I think
실질적이지 않을까 싶어요.
it will
차성수
be more meaningful to
한국원자력
have
환경공단
congratulatory
이사장님께서
remarks
특별
from
메시지
the CEO of Karat, Song-Soo Cha. Let us watch it together.
한국원자력환경공단 이사장
Hello everyone, I'm Song-Soo Cha, CEO of Karat. First of all, even though it was a quite difficult topic you may not be familiar with, I'd like to thank every contestant for joining the contest and providing really insightful and interesting ideas for the Radioactive Waste Management of Future Technology Idea Contest. Based on your ideas and video clips, I believe you are now able to imagine a better future of the rod waste management. And as we go forward using your ideas and video clips, we will try to put them or incorporate them into our projects.
Unfortunately, due to a stricter measure of phase-2 distancing, we're not able to hold a award ceremony on site. I'd like to ask your understanding. I would sincerely congratulate all the awardees today.
네, 다시 한번 축하드립니다.
Well, once again, congratulations. And last but not least, we're going to invite the Chang So-woo for her acceptance speech.
Hello, everyone. I'm a freshman at Daecheon Girls High School. My name is Bang So-woo. First of all, I'd like to thank Korea for giving me this opportunity to join the UCC contest. And preparing for this contest, it was a really good opportunity for me to learn about route waste management, which I did not know very well in the past. The route waste management movement tracking applications I created with the UCC, I hope it will be commercialized in the near future and helping the general public to have a better understanding. And I'd like to also thank my friends and others congratulating me for this award. Thank you very much. Okay, and many people paid a great attention in the contest, and it was really hard to pick the award winners. Now we have all the awards, provided. Already we have better understanding and better or increasing interest in the movement and management of route waste. And I think we have now taken a step further to the safer management of route waste. And of course, there are still room for improvement. That is the reason why we are gathered together. If we are participating and showing interest as we have today, I think we have a really bright future for safe management of route waste. Okay, and at the 7th Symposium, we had the opening ceremony and award ceremony as well. We will take a short break and then we will be back with topic presentations looking into the present and future. And we will take a 15-minute break. And during the break, we will have a quiz as well. So before we end the break, there will be a quiz. So please check the chat room. Thank you. We will be back in a minute.
2020년 코로나
안전하고 발전적인 미래를
방사선 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 포라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사능 폐기물 안전관리 국제 심포지엄 개최를 축하드립니다. 국가, 안전, 환경 모두가 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다. 앞으로도 미래 세대를 위해 힘써주세요. 화이팅! 화이팅!
방사선 폐기물 안전관리 심포지엄 화이팅!
제7차 방사선 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사선 폐기물 안전관리 심포지엄에서 방사선 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사선 폐기물의 안전한 관리를 위해 항상 힘써 주셔서 감사합니다. 한국 원자력 환경공단 응원합니다.
국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사선 폐기물 안전관리 국제 심포지엄 파이팅!
제7차 방사선 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사선 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
안전한 날과 뜻따뜻해주세요. 또디야.
코로나 속에서도
화이팅!
화이팅!
대한민국의 에너지를 책임지고 있는 원자력. 원자력 에너지 이용 과정에서 발생하는 방사성 폐기물 안정성에 대한 불안과 갈등은 계속되고 있습니다.
방사선 폐기물 관리에 대한 인식이 좀 우려스러운 우려를 또 할 수 있습니다.
신뢰받는 안전한 처분 시설, 건강하고 깨끗한 미래를 만들기 위한 노력은 선택이 아닌 필수가 되었습니다. 원전 수입국에서 원전 수출국으로 자리매김하며 세계 최고의 원전 기술을 자랑하고 있는 대한민국. 인정받고 있는 우수한 기술과 안정성에는 원전의 부산물인 방사성 폐기물에 대한 안전한 관리가 뒷받침되었습니다. 책임 있는 방사성 폐기물 관리를 위해 중저준위 방사성 폐기물을 안전하게 처분할 처분시설과 안전한 운송을 위한 방사성 폐기물 해상 운반 전용 선박 등 관리 기반을 갖추었습니다. 또한 인수, 운반, 저장, 처분을 하는 전 과정은 엄격한 기준과 안전한 설비를 통해 이루어지고 있으며 치밀한 원격 추적 관리로 안전성을 높이고 있습니다. 대한민국은 지금 국민의 안전을 최우선으로 하는 안전하고 깨끗한 에너지 전환 시대를 맞이하고 있습니다. 국가 에너지 정책 패러다임을 전환하는 과정에서의 최우선 과제는 바로 사용 후 핵연료 관리. 즉, 고준위 방사성 폐기물 관리 사업의 기반 조성과 처분 기술의 개발은 한국원자력환경공단의 중요한 과제가 되었습니다. 최고의 안전성으로 신뢰받기 위해 노력하고 있는 한국원자력환경공단. 에너지 전환 시대를 한 발 앞서 나간다는 사명감을 가지고 방사성 폐기물의 안전하고 효율적인 관리를 통해 국민 생활의 안전과 환경을 지켜나갈 것입니다. 지속적인 기술 개발을 통해 안전한 관리에 필요한 추진 기반 구축과 핵심 기술을 확보하고 신뢰할 수 있는 관리 정책을 실현시키기 위해 노력하겠습니다. 다음 세대를 위한 깨끗한 환경, 행복한 미래. 안전으로 신뢰받는 국민의 코라드. 한국원자력환경공단이 만들어갑니다.
2020년 코로나
국내의 안전하고 발전적인 미래를
방사성 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 코라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사성 폐기물 안전관리 국제 심포지엄 개최를 축하드립니다. 국가 안전, 환경 모두가 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다. 앞으로도 미래 세대를 위해 힘써주세요. 화이팅! 화이팅!
방사성 폐기물 안전관리 심포지엄 화이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사성 폐기물 안전관리 심포지엄에서 방사선 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사선 폐기물의 안전한 관리를 위해 항상 힘써 주셔서 감사합니다. 한국원자력환경공단 응원합니다.
국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
속에서도
화이팅!
화이팅!
대한민국의 에너지를 책임지고 있는 원자력. 원자력 에너지 이용 과정에서 발생하는 방사성 폐기물 안정성에 대한 불안과 갈등은 계속되고 있습니다.
방사성 폐기물 관리에 대한 인식이 좀 우려스럽다는 우려를 또 할 수 있습니다.
신뢰받는 안전한 처분 시설, 건강하고 깨끗한 미래를 만들기 위한 노력은 선택이 아닌 필수가 되었습니다. 원전 수입국에서 원전 수출국으로 자리매김하며 세계 최고의 원전 기술을 자랑하고 있는 대한민국. 인정받고 있는 우수한 기술과 안정성에는 원전의 부산물인 방사성 폐기물에 대한 안전한 관리가 뒷받침되었습니다. 책임 있는 방사성 폐기물 관리를 위해 중저준위 방사성 폐기물을 안전하게 처분할 처분 시설과 안전한 운송을 위한 방사성 폐기물 해상 운반 전용 선박 등 관리 기반을 갖추었습니다. 또한 인수, 운반, 저장, 처분을 하는 전 과정은 엄격한 기준과 안전한 설비를 통해 이루어지고 있으며 치밀한 원격 추적 관리로 안전성을 높이고 있습니다. 대한민국은 지금 국민의 안전을 최우선으로 하는 안전하고 깨끗한 에너지 전환 시대를 맞이하고 있습니다. 국가 에너지 정책 패러다임을 전환하는 과정에서의 최우선 과제는 바로 사용 후 핵연료 관리. 즉, 고준위 방사성 폐기물 관리 사업의 기반 조성과 처분 기술의 개발은 한국원자력환경공단의 중요한 과제가 되었습니다. 최고의 안전성으로 신뢰받기 위해 노력하고 있는 한국원자력환경공단. 에너지 전환 시대를 한 발 앞서 나간다는 사명감을 가지고 방사성 폐기물의 안전하고 효율적인 관리를 통해 국민 생활의 안전과 환경을 지켜나갈 것입니다. 지속적인 기술 개발을 통해 안전한 관리에 필요한 추진 기반 구축과 핵심 기술을 확보하고 신뢰할 수 있는 관리 정책을 실현시키기 위해 노력하겠습니다. 다음 세대를 위한 깨끗한 환경, 행복한 미래. 안전으로 신뢰받는 국민의 코라드. 한국원자력환경공단이 만들어갑니다.
2020년 코로나
국내의 안전하고 발전적인 미래를
방사성 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 포라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사선 폐기물 안전관리 국제 심포지엄 개최를 축하드립니다. 국가 안전, 환경 모두가 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다. 앞으로도 미래 세대를 위해 힘써주세요. 화이팅! 화이팅!
방사성 폐기물 안전관리 심포지엄 화이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사성 폐기물 안전관리 심포지엄에서 방사선 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사선 폐기물의 안전한 관리를 위해 항상 힘써 주셔서 감사합니다. 한국원자력환경공단 응원합니다.
국내 국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사성 폐기물 안전관리 국제 심포지엄 화이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
안전한 발바 스타트해주세요. 또요.
코로나 속에서도
화이팅!
화이팅!
대한민국의 에너지를 책임지고 있는 원자력. 원자력 에너지 이용 과정에서 발생하는 방사성 폐기물 안정성에 대한 불안과 갈등은 계속되고 있습니다.
방사선 폐기물 관리에 대한 인식이 좀 우려스러운다는 우려를 또 할 수 있습니다.
신뢰받는 안전한 처분 시설, 건강하고 깨끗한 미래를 만들기 위한 노력은 선택이 아닌 필수가 되었습니다. 원전 수입국에서 원전 수출국으로 자리매김하며 세계 최고의 원전 기술을 자랑하고 있는 대한민국. 인정받고 있는 우수한 기술과 안정성에는 원전의 부산물인 방사성 폐기물에 대한 안전한 관리가 뒷받침되었습니다. 책임 있는 방사성 폐기물 관리를 위해 중저준위 방사성 폐기물을 안전하게 처분할 처분 시설과 안전한 운송을 위한 방사성 폐기물 해상 운반 전용 선박 등 관리 기반을 갖추었습니다. 또한 인수, 운반, 저장, 처분을 하는 전 과정은 엄격한 기준과 안전한 설비를 통해 이루어지고 있으며 치밀한 원격 추적 관리로 안전성을 높이고 있습니다. 대한민국은 지금 국민의 안전을 최우선으로 하는 안전하고 깨끗한 에너지 전환 시대를 맞이하고 있습니다. 국가 에너지 정책 패러다임을 전환하는 과정에서의 최우선 과제는 바로 사용 후 핵연료 관리. 즉, 고준위 방사성 폐기물 관리 사업의 기반 조성과 처분 기술의 개발은 한국원자력환경공단의 중요한 과제가 되었습니다. 최고의 안전성으로 신뢰받기 위해 노력하고 있는 한국원자력환경공단. 에너지 전환 시대를 한 발 앞서 나간다는 사명감을 가지고 방사성 폐기물의 안전하고 효율적인 관리를 통해 국민 생활의 안전과 환경을 지켜나갈 것입니다. 지속적인 기술 개발을 통해 안전한 관리에 필요한 추진 기반 구축과 핵심 기술을 확보하고 신뢰할 수 있는 관리 정책을 실현시키기 위해 노력하겠습니다. 다음 세대를 위한 깨끗한 환경, 행복한 미래. 안전으로 신뢰받는 국민의 코라드. 한국원자력환경공단이 만들어갑니다.
2020년 코로나
Now you are joining the 7th International Symposium for Safe Radioactive Waste Management. I hope you enjoyed the break and you got the right answer for the quiz. I hope that many people to win the gift. We will now resume the symposium with the keynote presentation. Following the keynote presentation, we have a Q&A session. So for the presentation, if you have questions in the middle of the presentation, you can put your questions on our YouTube channel. So right after the keynote presentation, we will have a questions and answer sessions. All right, then let me invite Pang Tae-won, the Institute Head of CORAD, for keynote presentation on high-level radioactive waste management R&D status. Hello, everyone.
원자력 환경공단 방사성 폐기물
I'm
연구소장
Tae-won Hwang,
황태원
Institute Head for R&D
우선
of radioactive waste at Korea,
사람 심포지움에서
at CORAD.
한국의
And first of all,
사용의 관리와
I'm very
관련한
delighted to
기술
deliver
개발 현황을
a
말씀드리게 된
keynote
것을
presentation
매우
on
기쁘게
R&D program for
생각합니다.
managing spent nuclear
잘
fuel in Korea
아시다시피 사용 후 해결료를 포함한
at the
꾸준히
7th SaRaM
방사성
Symposium.
폐기물의
As you well
관리는
know,
매우
management
긴
of
시간
high-level
동안
radioactive waste, including
안전성을
spent nuclear
담보하여야
fuel,
하기
must
때문에
ensure safety for a
전
long period of
세계적인
time.
관심사이다. 특히
Therefore, it is an issue
안전성을
of
확보하고
increasing
검증하기
international
위한
interest, and in
체계적이고
particular,
종합적인 국가
in order
차원의
to
연구
ensure
개발
and
시행이
validate
매우
safety,
필요한
systematic
프로젝트입니다.
and comprehensive R&D activities are
이러한
strongly
중차대한
required at
프로젝트의 효율적
national level.
수행을 위하여
To effectively conduct
한국에서는
such a critical project, the Republic of
산업통상자원부,
Korea, based on cooperation
과학기술정보통신부의
among relevant government bodies, including
원자력안전위원회 등
Ministry of
관련
Trade, Industry and
정부부처가
Energy,
함께
Ministry of
참여하는
Science and ICT,
부처 간
and
협력을
Nuclear Safety
기반으로
and
한
Security Commission
향후 5년
has
동안
developed
수행할
a spent
사용
nuclear
후
fuel
해결료
technology
기술
development
개발
plan,
계획을
which will
기획하였고
be implemented
내년
for 9 years
2021년
starting from
수할 예정입니다.
2021.
또한 사용 후
In
해결료를
addition,
안전하게 취급하고
to
관리하기
develop
위한
a facility
시설
concept
개념을
for safe
개발하기 위해서
handling and management of
산업부
spent
전담으로
nuclear fuel,
추진될 연구 개발
an
프로젝트도
R&D
동시에
project
추진이
led
계획되어
by
있습니다.
the Ministry of Trade, Industry and Energy will be conducted in parallel.
예, 오늘 말씀드릴 순서는
The order of
한국의
my
사용 후
presentation
해결료
today
관리 현황,
is an overview
과거에
of the spent nuclear
추진된
fuel
연구
management
개발
status in Korea,
성과들을
followed
먼저
by past R&D
설명드리고 그
outcomes.
후에
Then
앞서 언급한 두 개의
I will
대형
explain
프로젝트에
the
대해서
2 larger scale
예상
projects I
성과
mentioned
및
earlier,
추진
as well
활동에
as their
대해서
expected
설명드리도록
outcomes and
하겠습니다.
activities performed.
네, 고준위 방사성 폐기물 수행 체계 및
Let us first
현황에 대해서
take a look at the
살펴보겠습니다.
national framework and current
사용
status of
해결료
high-level
관리와
radioactive
관련한
waste.
정부 부처는 사업을 담당하는
As government bodies related to management of spent nuclear fuel, we have the Ministry of Trade, Industry and Energy in charge of the projects, the Ministry of Science and ICT for developing source technology, and the Nuclear Safety and Security Commission, a regulatory body. CORAD is commissioned by the central government for a mission to safely manage spent nuclear fuel.
네, 사용 후 해결료 관리를 위한 중장기 계획을 마련하고자
In order to establish a mid to long-term plan for spent nuclear fuel management, the government, CORAD, and other relevant organizations have put great efforts. As part of such efforts, a basic plan for high-level radioactive waste management was developed in 2016. In this plan, comprehensive plans for site selection, interim storage, and final disposal were included. However, since 2019, according to the energy transition issue, which is a global trend, the Republic of Korea has been re-examining the second spent nuclear fuel management policy. There is a broad consensus already that basic technologies for spent nuclear fuel management should be continuously developed. Let me briefly explain outcomes of technology development activities conducted by CORAD. First, about technology development related to storage and transportation of spent nuclear fuel. In order to secure design technology for storage and transport casks, from 2009 to 2016, we conducted a research project. As an outcome of this project, we developed a dual-purpose metal cask, CORAD 21, which is able to load 21 spent fuel assemblies, and CORAD 21C, a concrete cask for dry storage. We have applied for a design license on transport conditions in 2016 and currently waiting for a review result from the NSSC. And another R&D outcome, we also developed a database system by securing data on geological disposal and human social environment to be used for site selection regarding spent nuclear fuel disposal. Based on these outcomes, we are conducting thermal structural shielding analyses to evaluate materials for disposal casks, and we are making efforts to secure basic technologies for safe management of spent nuclear fuel. Now, let me explain our mid to long-term technology development plan. The objective of the mid to long-term technology development plan is to secure technical capabilities essential for safe management of spent nuclear fuel. Development activities include safety validation for dry storage of spent nuclear fuel, developing methodologies for disposal system development, and developing regulatory requirements related to deep disposal. At present, the scope of technology development plan is to secure core technologies associated with concept design of the management facilities marked in blue and storage and disposal marked in yellow. Now, let me explain the technology development plan mentioned before more in detail. First, I will explain a project to develop core technologies to ensure safety of spent nuclear fuel storage and disposal, which will be implemented across various government bodies. This technology development project is to secure core solutions of storage and disposal to establish a safety management systems of spent nuclear fuel, and it will be implemented based on 3 areas and 7 project tasks.
Next, 3 main projects to secure technology. First, it is to develop safety demonstration technology for spent nuclear fuel storage system and establish standardized data system and list of safety data of entire life cycle. Second, it is the identification and verification of disposal safety. We're planning to carry out development of site conformity assessment technologies, development of safety assessment based on safety case, and development of performance demonstration technology of the deep repository system. Third, establishment of the safety regulation of SNF deep repository system. With this aim, we will develop detailed regulatory requirements and verification system for safety of the deep repository system. I will now introduce to you the implementation system of the project. The 3 main projects and their linkages are shown in this picture. Based on the existing core solutions for SNF storage and disposal will be developed and management base will be established. I have explained to you about core technology development for spent nuclear fuel storage and disposal so far. Next, I will shift the gear to the development of design technology for SNF management facilities. The goal for this task is to confirm the concept on SNF management facilities and carry out concept design. To this end, we'll create disposal concepts suitable for our geological environment, and through various scenarios, we will analyze economic viability and safety to come up with an optimized plan for management. The duration for the project will be around a total of 5 years from next year, and the project will be divided into 3 sub-projects to be carried out. In detail, the first sub-project is to develop design technology for SNF management facilities. Therefore, we'll analyze design procedure and concept design of disposal facilities and design requirements for management facilities and equipment. The second sub-project is to develop safety-related technology for SNF management phase. To this end, identification of influence factors among management phases and establishment of an evaluation system and concept plan for linked instrument as well as performance evaluation system. Third sub-project is to develop feasibility assessment technology for SNF management facility design. The main research areas for this will be the definition of characteristics of deep rocks in Korea and preliminary characterization and feasibility and performance assessment system for safety of the management facilities. This slide shows connectivity of sub-projects. The R&D by sub-projects will be carried out annual basis. With this connectivity, we are planning to develop design technology for SNF management facility, which is the ultimate goal. I'll now talk about expected outcome from the technology development plan that I mentioned earlier. Through the technology development that I have mentioned so far, I think we can secure core technology for life cycle safety management of SNF. By securing core technology required for the interim storage of SNF, disposal facility construction, and approval, we can be free from interdependency of overseas technology, and we, along with the expansion of the related local industries, we can expect a job creation effect. The plan for technology development that I talked to you will enhance research quality by outcomes from the already implemented research and development. Storage system safety demonstration technology, disposal safety defining technology, and safety regulation technology will be developed based on the plan and will be used as demonstration material in building generic URLs, which is planned to be secured in the future. Through the aforementioned technology development, we can secure safe management technology for SNF. And as for the SNF management project, I think we can contribute a lot to improving public awareness and acceptance. Thanks for listening. Thank you.
Well, thank you for the keynote presentation. I hope you enjoy the keynote presentation. So the challenges we need to solve, he highlighted, and as well as the future direction. You may but want to know more in detail, so we will have a Q&A session briefly now. We have a first question available on the screen. Yes, all right. And it's about the technology development, current status and future on the deep deposit disposal, and also how it will be developed in the future. So Mr. Huang, are you listening? All right. And please answer to the question. Yes, about the deep disposal environment and how to evaluate it, how to to manage these spent nuclear fuel and in general the road waste. Of course, we need to secure the safety for a long period of time. It is is the most important factor in the rod waste management. So, of course, deep geologic disposal, there are many technologies involved, and below surface level 500 meter, many countries are developing their technologies for the deep disposal, and obviously it will have a great impact on the environment. So, to clearly understand the environmental impact is one of the key elements for the deep disposal of the rod waste. If you look at the conditions in Korea, of course, we have aquifer, underground waters. We are assessing and analyzing their characteristics, and including pressure. In addition, the fracture characteristics of the rocks we are analyzing and interpreting, and they are implemented as well, but still they are quite limited and localized. So to dispose our spent nuclear fuel with a large scale, there is a still limit. So, and we do not have enough experience yet. So, to tell you more in detail how they are doing in other parts of the world. So, for the deep disposal of spent nuclear fuel, already the leading countries in other parts of the world, many have already completed related researches and surveys, and they are applying those technologies and experiences in practice. So, and for example, in Switzerland, which will actually have them implemented for deep disposal starting from next year, they already developed demonstration and other related technologies and evaluated. The same goes for France as well. So almost the real time or the life scale, the depository assessments have done in those nations. In France and Switzerland, they are the leading ones. So they have utilized the 3D survey or investigative methods because it is very helpful to minimize the disturbance in the underground environment. That is why they are using these technologies. So based on these technologies and methods I explained for deep disposal evaluation and assessment on the environment, I believe so far in Korea we have only small scale, limited scale demonstrations or experimentations. So at the moment we do not have a larger scale demonstration yet. So to utilize those projects and technologies, we have a great need. So as I mentioned before, to store and dispose and ensure safety of spent nuclear fuel, we need to develop core technology. So in our second core technology development project, we will focus on the site development and assessment of suitability, and related technologies will be developed further. Thank you.
Well, thank you very much. For the first question, he mentioned about a current situation at local level and also future direction. Next, we're going to pose the second question. Then when it comes to the what about the technology development of the overseas in this area? So could you address this question? Could you answer right away? Yes, of course. When it comes to the current situation of overseas, we are actually conducting the cyclical analysis. And when it comes to the safety regulation, the U.S. is the leader. Already in 1970s, for the cask, they have conducted the safety analysis, and it is in the final stage. And for the dry storage facility, they are intensively investing. And for Korea, in order to find out the economical safe way of using that, the analysis and demonstration pilot tests are being carried out, and as a main project by the multi and pan-government ministerial level, and this will be implemented soon. And when it comes to other project, Dr. Lee Jung-han has contributed a lot, so he is the right person to give this answer, I think. So I will hand over to him. Good afternoon. I am Lee Jung-han from Korea, and for your question, I'm going to talk about the domestic situation. When it comes to the U.S., When it comes to the sound test, the international organizations also consider this aspect very important. So we are considering that. So when it comes to the Sweden, stainless and they are conducting a corrosion test on the steel and other materials. And also in Japan, this kind of tests are being carried out. So in order to see the sound test, the metal part for the canister, and also for the integrated test, and for the test, as this will take a long time. So for the integrated test in Korea has already begun this analysis for long.
Thank you for the answers. It certainly helped our understanding. Okay, we will move on to the next question right away. But if you look at here, there are many people who wants to understand the current status of overseas. Well, what about this one for deep disposal, the engineered barrier, and how to assess the long-term integrity of the engineered barrier, and how the technologies are developed abroad? Yes, in the Central European nations, there are very active. Researches and developments are underway. And for example, in Finland, starting from 2022, high-level waste, the disposal facility will be, and license will be given. And I believe next year in Sweden and France, they will make an application for a license. So for deep disposal, the containment related to it, not only to the European nations, and U.S. is leading the research activities. So as mentioned before, in the Switzerland, Green Cell UR, there is a kind of experimental facility underground. So the bentonite engineered barrier material is experimented and studied in a life scale. So hydraulic and thermal and mechanical characteristics are analyzed. So Sweden used to be the leader in this field in one of their research institutes. They also analyzed the bentonite characteristics, the compact compression and other characteristics to better understand the material. Also, the life scale demonstration, and they are still continuing. And last but not least, in the United States, in one of their projects for different rocks, they are evaluating the thermodynamic and hydraulic characteristics. They are checking the stress, temperature, and other properties of the various rocks to be used for potential repository. I hope this answers your question.
Well, that was a very sufficient answer, and by country, and there are some direction that we should follow was mentioned. Next, we're going to move to the next question. All these are very contents and topics that will be discussed in different manner. So we don't have enough time to address your questions, so I feel sorry about that. When it comes to site selection project, how is the technical outcome should be based, and how is it going? We had a lot of challenges site selection for 19 years. We have concentrated our capabilities, and going forward, we have to do more to select a site for the SNF. So what kind of criteria must be applied and for the site, whether that is suitable or not? How do we evaluate? Well, how will be the procedures to be applied? We need to have this kind of preparations. For that, as I've mentioned, the huge project which will be launched next year, we're going to begin. For example, when it comes to a technology development project for the SNF management, the site qualification criteria must be submitted, and second, to secure the safetiness of the SNF management and storage, for the follow-up, the evaluation criterion system should be introduced to provide a appropriate or the suitable level for the evaluation. And now we have been benchmarking the Sweden model. So engineering feasibility and evaluation method must be created based on their model, and then we are successfully carrying out this site selection process, and we'll definitely come out with a huge an outcome.
Thank you for your answer. Well, so we are diving into very in detail, and he has given really good answers. And this clearly proves that how hard he's working in research activities in this manner, and we are making step-by-step improvements. Well, we do not have a lot of time, so it will be our last question to take. So last but not least, I think this should be asked. Well, the plan to develop the SNF, the management. Once it's done, what about the direction of the further, technologies? Well, just because we have developed all the technologies, it's not the end. As I mentioned before, the outcomes from these technology developments, how we are going to apply them in reality and how to validate them, that is the important step following the development of the technologies. That is the direction we should go ahead. And to give you some examples abroad, some countries have already successfully, disposed, and others are working still. And there are some research facilities, and based on their, the research activities, based on the safety validated, they are applying these technologies in practice. But there can be some limitations because each nation have their own respective, the bedrocks, so to enhance their effectiveness, to operate their underground repositories. So in total, there are roughly 16 in operation. For example, China and Russia are constructing their underground research facilities. So not only for demonstration activities, but for enhancing the storage capacities of spent nuclear fuel. These are very good and beneficial projects to develop, not just develop technologies, but also for validation and demonstration. We have high expectations as well. So to achieve these purposes, of course, it costs quite a lot of budget. So in advance, we would like to have a really thorough analysis in advance, comprehensive investigation. And once we have a clear understanding, then we will take a step further.
Well, thank you very much, Doctor. As you mentioned, as it's not that we finish one and then move to the next step, but we have to carry out in a continuum basis to ensure the success. We do agree with that. I believe all people also agree with that, and I believe thanks to your efforts, our public are safely living together. So in this sense, I would like to thank all the speakers and a speaker who answered. And we just heard from the local experts, but now we're going to move to international speakers' presentations to see and compare with the local current situations and also the technology level and the plan. First, we're going to invite Fernando Lobrado from the NRES Spain is going to talk a presentation.
Good morning, everybody, and thank you very much for the attendance. First of all, I would like to thank Garad for letting me participating in this symposium. It is always positive for a company like mine to participate in international congresses or conferences to guarantee technical cooperation and collaboration between companies with similar missions. So first of all, thank you very much. And I hope you like the presentation. So the purpose is to give an overview about the Spanish centralized interim storage facility for spent fuel and for high-level waste, focusing on the research and development activities performed to fulfill these the design objectives. So first of all, I'll explain the national policy and strategy for radioactive waste management, including the spent fuel. Secondly, I'll describe the centralized facility project, focusing on the main design characteristics. And at the end, I will finish with the description of the research and development activities and plan established in this context. So, let me introduce a little bit the context. In Spain, according to the national law on nuclear energy, the government shall establish the national program and policy on the management of fuel and radioactive waste, and on the dismantling and decommissioning activities of nuclear facilities by means of approval of the General Radioactive Waste Plan, the so-called GRWP. The technical review of the plan is proposed every 4 years or when requested by NRESA, okay, or by the government. And yeah, and NRESA is the national company entrusted with the dismantling and decommissioning activities, and of course of the management of radioactive waste. So the general plan has to be approved by the government when having succeeded the positive assessment on nuclear safety and radio protection by the regulatory body, the CSM, and after hearing the autonomous regions on urban planning and environmental related issues. And the plan is also submitted to the national parliament for information purposes. The plan, General Radioactive Waste Plan, addresses the strategies, the necessary actions, and the technical solutions to be taken into account and to be developed in the short, medium, and long term in order to ensure the spent fuel and radioactive waste adequate management. It also includes an evaluation of costs and the applicable financing regime, and finally also addresses the research and development activities needed, which is the focus of this. In this context, the first plan was approved in 1987. It means more than 3 decades, and it has been several times updated, and the current version dated from 2006. The government has recently addressed the so-called National Plan for Energy and Climate for 2021-2030, and the 7th draft of the radioactive waste plan is being prepared for its official processing, taking into account this National Energy Plan for Climate and Energy. Okay? So this is a little bit about the context. What about the strategy? The overall strategy of nuclear energy in Spain implies the assumption of an open cycle decision, which was made in the early 80s. In this framework, the Spanish national strategy for the management of high-level waste, including the spent fuel, is based on an integrated approach and aims for their future disposal in a deep geological repository, a DGR. And it's important to outline that this is in line with the broad international consensus with Directive 2011-70 Euratom, which recognizes that a deep geological repository is the most sustainable and safe option for the long-term management for spent fuel and high-level. As many decades are needed in Spain to develop this repository, this final repository, an intermediate solution has been taken into account since the second general plan, since 1989. And this is the centralized storage facility, which The project has been several times rescheduled as a result of the evolutions and changes in the nuclear program in Spain. The licensing process started in 2013, but the State Secretary for Energy requested the regulatory body to temporarily suspend the issuance for the construction. To take into account the new draft of the General Radioactive Waste Plan. So this is a little bit about the context. So, as stated before, the general strategy in Spain is based on an integrated approach. And this means to look for long-term disposal solutions in a deep geological repository, and in the meantime, to provide enough capacity to allow the operation of the nuclear power plants. Once the spent fuel is definitively discharged from a nuclear reactor, it is stored on the on-site temporary storage pools in the plants. All the Spanish nuclear power plants has its own pools, except for 2 of them, which are currently under dismantling. As the centralized facility is not yet available, it has been necessary to undertake several actions in its plan to allow either the operation or the starting of the decommissioning activities. Almost all the nuclear power plants in Spain did re-racking rules in different stages. Means the substitution of the original racks for more compact units to increase the storage capacity of the pools. Of course, taking into account the results of the safety analysis, especially the criticality. Beyond the re-racking projects, in the pools, the Spanish national strategy considers the option of construct on-site dry storage facilities, known as individual storage facilities, ISF. And once the centralized facility could be available, these interim storage facilities on site in the pools could be used as logistic support areas that could facilitate the facilities for transportation of the fuel. As the common rule, this kind of facilities has been licensed as design modification of the plants according to the regulation of. So, how it is the decentralized facility? So the main functions are as follows: are to receive, handle, and temporarily storage all the spent fuel coming from the nuclear power plants operation, and all the high-level waste coming from the reprocessing of some fuel elements which has been sent to LAC facility in France for reprocessing. Other functions of the centralized facility is to receive, handle, and temporary storage the special waste, which includes other residues coming from but also some waste coming from the nuclear power plant decommissioning activities and some disused radioactive encapsulated. And the facility has other complementary functions, for example, some research and development activities related to the spent fuel behavior. Quite important for the development of long-term solution. So the main characteristics are as follows. It is designed based on a dry storage technology, and the safety functions are covered as we indicate here, okay, in the presentation. The confinement is ensured by a double barrier, well by the canisters or wells, or by the gas. The heat removal is always based on passive measures by natural convection. The subcriticality conditions are always ensured by the fuel elements geometric disposition inside the canister or inside the gas. The shielding is provided by reinforced concrete walls, thickness and gas, and the retrievability is also a safety function according to the Spanish regulations. And the lifetime design is 100 years. So the main process is based on three buildings, as you can see here. Okay, the reception building, the process building, and the spent fuel high-level weight estimate. Okay, so three buildings. In the reception building will be held the main operations of reception of the loaded transportation gas, building the system removal, contamination controls, and flip it into vertical position. Once the canister, the transportation gas is flipped into vertical position, it is put in the transfer trolley and it enters the process building. Okay. In this building, the main operations are the opening the transportation gas, to unload the spent fuel elements from the gas and to load it into a specific canister. Once a canister is completely loaded, the external lid will be placed, and all the operations related to the vacuum, inerting, and tightness and controls are performed in a transfer tunnel. Finally, when everything is tested and everything is okay, the canister will be put into a specific vault for storage, where passive cooling will allow the decay. So, which is the research and development activities? Here you can see a little bit of the which are the main lines or the main aspects identified for this kind of facilities. You have aspects, or you have to develop some research and development activities in terms of the design, for materials, structures, processes, in terms of sites issues, for example, to study which is the radionuclide migration or the solid structure interaction, some methodologies to improve the safety analysis, and some human factors and training. But we are going to cover this taking into account the research and development plan issued by ENRESA. ENRESA, the national company, has a research and development plan, and it is issued every 5 years, and it takes an average approximately, the median is approximately 30 million euros. The current plan in force is the 8th plan, and you can see that all the research and development activities are divided or put into specific lines. We have 5 lines of investigations. The waste technology, the treatment, conditioning and dismantling, the materials, the performance and safety assessment, and the infrastructure and coordination. The waste technology covers everything related with the characteristics and performance of the radioactive waste throughout different stages. The second line is more related with dismantling, so it doesn't apply to a centralized storage facility. Okay. The third line is materials and confinement. Here is everything related to materials and structures and components. So this is a research and development plan for the centralized facility. The fourth line is the performance and safety assessment. So it covers all the methodologies to improve the knowledge in the safety analysis. So it is quite important also for the decentralized facility. And the fifth line is more general, related with the knowledge management of all the companies. So we are going to focus on waste technology, materials, and performance and safety assessment. So related with the waste technology, the most important part, of course, is the spent fuel, the spent nuclear fuel behavior. So we have completed some projects. For example, a project related with the experimental measures of isotopic composition to try to optimize the radiological impact estimations to reduce the conservative hypotheses and uncertainties. We are covering some projects related with the exfoliation or expelling of the spent nuclear fuel to analyze the fuel handling capacity by normal means, it means by a single failure crane, the structural resistance and the long-term behavior of this kind of fuel elements. We have covered many projects and we are going to cover more projects related with the oxidation of spent fuel in non-inert atmosphere for the unloading cell, okay, to enhance the safety analysis and to provide more confidence on the safety analysis, okay, and the objective, of course, is to analyze the structural resistance and the long-term behavior. And we have also developed some projects related with the storage and transportation gas to develop some analytical capabilities, to perform some fuel thermomechanics simulations and some thermofluid dynamics. The main objective is to verify always the behavior of the spent fuel during storage inside the gas. And we have also developed some projects about the reprocessing waste, some liquefied and compacted canisters. For example, we have developed a specific project to analyze the hydrogen generation during storage conditions. Okay? And this is quite important because there is some international cooperation with similar facilities. For example, Habo in Holland or LAG in France. Related with materials and confinement barriers, we have developed some projects investigating the sites, for example, to enhance our knowledge of hydromechanical and geochemical response, as for example, to analyze which is the radionuclide migration at the site, to develop the long-term impact and which is the impact in the safety. But much more important is the studies performed for materials. We have some projects about the durability of metallic materials, for example, for canister, for gas, or for neutron absorbers, to increase the level of knowledge about the behavior of new materials, to select the most sustainable material for each component, to analyze also which are the most optimized manufacturing methods, and to know and to analyze the behavior under extreme conditions, radiation and temperature. We have also developed many projects about or studying the concrete structures of the facility. Here you can see the facility, so the structures of facilities, which is the best. The first thing is to identify which are the seismic the seismic requirements for the structures, to select the most sustainable materials for including the aggregates, and to analyze which is the durability of these materials under the operating conditions. And we have also developed some projects. Currently developing some projects about for canisters and wells. This is the heart of the facility. So we have analyzed the design requirements, the most sustainable manufacturing methods, how can it be put into an industrial scale production, and to optimize the cost. So everything is very important to have a whole study of these kind of materials, because we are going to produce many canisters and many wells. So this is quite important to cover all these parts, not only safety, but also industrial production, cost optimization, etc. And as I previously commented, the process for this facility is based on remote and automatized processes. So, for example, for the welding of the canister, you have to develop these operations using a remote technique. So we have analyzed different industrial techniques and also the inspection testing to fulfill the testing regulatory requirements, and to analyze the behavior of these processes under extreme conditions. So this is quite important also. Okay, Well, we have also covered some projects, for example, for the leak tight specific canisters to be appropriate for the storage of damaged fuel elements, of damaged roads, and to also to develop the most interesting inspection testing for the canisters. Well, we are thinking to develop some projects related, for example, for the cameras of the facility, because we have to develop a specific shielding materials and process which would be able to operate under extreme radiation conditions. And to develop, for example, some decontamination procedures prior to storage. And to finalize, well, we have developed some projects, and we are going to cover more projects about the safety analysis modelization. Everything related with safety analysis, thermo-hydromechanical behaviors in the long term, the ground floor modeling, the iodine in-air measurements, for example, the explosion analysis for aircraft impact scenario, which is a beyond design-based scenario for our facility. We have to cover everything related with explosions and the thermal behavior of these materials. So we have covered many projects related with that. So in general, I tried to cover some projects that we have already performed in our facility. I want to point out that the research and development is very important for a facility completely new with a new design. So this is one of the most important engineering parts of the process. So this is everything. I hope that the presentation covered your expectative and your objective. Well, if you should have some questions, well, please feel free to send by mail or the best way you want. Thank you very much.
Well, thank you for the presentation. Among many, the foreign cases, we first checked the current status of Spain from ENLISA. Yes, there are a lot of experts, but in the road waste management, Spain is one of the best. So it was really interesting and insightful. Let us move on to the case of Switzerland. Irina Gauss from NAGRA, under the topic of NAGRA's research and development plan for the management of high-level radioactive waste.
Thank you for inviting me to this conference. I feel really honored. In the next 20 minutes, I will give an overview of the NAGRA research and development for high-level radioactive waste disposal, its short-term and long-term perspectives. The presentation will consist of 3 parts. So first there is an introduction to the NAGRA program and disposal concept, then the shorter term perspectives until 25, and then the long-term RD&D perspectives. Here you see an overview of the Swiss waste management concept. There are 5 nuclear power plants. The high-level waste, which consists of spent nuclear fuel and glass, will go into the high-level waste repository. The low and intermediate level waste will go into a repository, which might be co-located with the high-level waste repository or not. This is to be seen. This is a short overview of the history of the high-level waste program. We started in 1978. It will go for the operation of the high-level waste repository until 2060. So we have quite a long time behind us, but also a long development time before us. Currently, we are in the stage of a sectoral plan. I will come back to that later. And the submission of the general license application, which is the license for the site, this is planned to happen in 2024. What is already sure in Switzerland is that we will host the dispose of the high-level waste in the opalinous clay. So basically our concept is a clay-based concept. The opalinous clay is a clay layer which is around 100 meters thick and has a very low hydraulic conductivity. Therefore, it's very suitable for hosting the high-level waste. Here you see an insight in the many RD&D activities we have been conducting in the last 20 to 30 years. Basically, there's a full understanding now on how the favorable properties of the opalinous clay contribute to the disposal concept. This is the NAGRA reference concept for high-level waste. What will happen is that we have a horizontal emplacement concept where the canisters, which contain either spent fuel or vitrified waste, will be placed onto a pedestal of bentonite. It will, the engineered barrier around it will consist also of bentonite, such that the properties are very similar to the host rock, and then the repository will be closed. This is the reference project. So it is already certain how the reference will look, most likely. However, where we will build the repository is not yet decided, and this is part of the sectoral plan. The sectoral plan describes how the sites should be selected in Switzerland. It is basically a set of rules for the site selection. The sectoral plan goes back to how to place big infrastructure works such as airports in Switzerland. So it follows a similar logic. The site selection occurs based on 13 technical criteria related to 4 groups, as shown here. Currently, we are in stage 3. At the end of stage 2 of the sectoral plan, there are 3 stages. We have brought forward 3 sites to locate the high-level waste repository. These are all located in the northern part of Switzerland, and all are located in the opalinous clay. So the stage 3 now is the aim is to select the site, the final site where to locate the high-level waste repository. This stage 3 where we are in now, it's we have started the investigation in 2015 and it will end in 2024. We have a very strong exploration program which consists of 3D seismics, exploration of the quaternary deposits, and also a deep drilling program. Ultimately, these activities will feed into the site selection and the application for a general license in 2024. This general license is different from the construction license, which will come later, and I will explain that. It determines on which place to have the high-level waste repository and the basic principles of the concept. So how does this now feed into the RD&D program of NAGRA? I will first talk a bit about the short-term RD&D perspectives. In order to do that, I want to bring the logic of the safety case. What we're doing now is preparing the safety case and the site selection. So we have to make sure that every aspect of the plant repository, that we can feed in answer the safety functions and reduce the uncertainties related to that. So I will go from the inside to the outside and highlight some of the RD&D activities that we are currently doing in order to prepare for the safety case, which we will hand in 2024 most likely. So first I will focus on the spent fuel properties, the canister loading, and also canister lifetime. So as already 20 years ago, it was approved that we could actually make a safety case. We're now updating the current safety case. So it's really focusing on remaining uncertainties. The science behind it is quite mature already. One of these remaining uncertainties is the spent fuel integrity. Because the spent fuel is in dry storage slightly longer than anticipated, we have to make sure that the properties are guaranteed for repackaging of the waste. And in order to do that, we have a laboratory program, and this is an example of the activities we're doing there, where we try to get insight in how the spent fuel evolves during longer periods of dry storage. This is together with Germany. We're doing this work. It's being done in Karlsruhe. Another activity we are heavily involved in is the activation calculations we do for the nuclear power plants. We have the capacity to actually calculate the activation level based on the the detailed design of the nuclear power plants to estimate the activation level of the different parts such that the packaging and the disposal can be optimized. This has been applied in Switzerland, but also in other countries such as Germany and also Greece. Then the first real barrier next to the waste, of course, is the canister, and therefore we have a canister program which is now based on the reference as a carbon steel canister, but we also look at various options. For the general license to be put in 2024, we're now developing this reference further. Canister coating with copper is also an important topic as an alternative, and for that we work together with the Canadian program. So moving out a bit further in our preparation of the safety case, we entered the area of the engineered barriers. As I said, the high-level waste concept in Switzerland is a bentonite-based concept. And in order to test this concept and get the confidence that we can, it will actually perform as we wanted to perform in the safety case, we have done this FE experiment in the Monterrey URL in Switzerland. Here you see how this experiment was set up. So basically we have placed 3 canisters, which were not, which were heaters, they were not real canisters, in a 1-to-1 experiment in a tunnel and surrounded them with bentonite. This already happened in 2014 when we started the heaters. The construction started in 2014 and then gradually it was expanded. Here you see an overview of how this experiment was built. This is an experiment which aims to run for a very long time, for over 10 years, because we want to check the long-term performance of the engineered barriers, but even more importantly, of the opalinous clay surrounding the engineered barriers. What we also did during this experiment was actually checking the technological readiness level of the various components of this experiment to see how well we would be able to construct our reference concept when it would come to constructing the repository. As you can see here, for each step we evaluated how far we were and what still needs to be done in the future to make this up to the construction license. Now move out a bit further. So once you have the engineered barriers, you come into this environment where you have all these thermal, chemical, biological processes. You need to monitor that and ensure that the performance of the components can be confirmed. So a few examples here. This is a very important area of work we currently focus on, in a sense that we need to have a very good description of how the repository will evolve over the coming decades, but also over multiple thousands of years. As this is a clay-based environment, you have a highly coupling between the processes, whether these are thermal, chemical, mechanical, or also hydraulic. So you need really, through model sequences, experiments, upscaling natural analogs, to develop this full insight on how this repository will develop. And this is an important aspect because this is a key aspect for the safety case. Here you see optimization. Gradually, now that we have high confidence in our reference, we're looking also towards optimization. And one of these topics we're currently looking at is our means to how to consume hydrogen. Hydrogen is being produced in the repository by the anoxic corrosion of steels. And there are ways actually to limit the pressure buildup due to the production of hydrogen. And this is one of the bioreactors we're currently testing in the Monterrey underground research facility. Monitoring is of key importance. It is not only monitoring of the FE experiment as is shown here, but it's also monitoring of the background at the different sites. It will be also repository monitoring in the future. Therefore, we're following up closely on the evolution of new monitoring and are actively involved in certain developments, such as fiber optics. Moving out a bit further, so we come really in the host rock, the geological environment, and I want to highlight a few points there which are currently important for our safety case for the general license to be submitted in 2024. The first one is self-sealing. If you have a concept in clay rock, you want to rely on the property of self-sealing of the rock, which says that if something unexpected happens to the rock, whether this is fracturing due to a seismic event or fracturing due to gas pressure buildup or thermal fracturing, that there is the property that the rock seals after the event. Now, self-sealing has been looked at in great detail already for decades, but the process understanding of how this actually happens can be further explored. And this is what's being done by these laboratory investigations, which are completed together with MIT in the United States. It actually shows the mechanistic understanding of self-sealing in the fractured opalines clay, but also the hydraulic properties of recompacted opalines clay, for example, as fracture fillings. Very special to the Swiss disposal program is the fact that the repository will be located very close to the Alps. When you say Alps, you think about glaciation, and this is how the last glaciation period looked in Switzerland. So you see that where now we have snow on top of the mountain chains. At that time, the snow and the glacier really extended into the areas where we currently foresee the repository to be. As a consequence of these glaciations, they have a lot of force and they are able to make these over-deepened rock channels. And this is where the issue comes up. Of course, for our safety case, we don't want to have such an over-deepened rock channel on top of our repository, because easily it can erode 300 to 400 meters of the overburden. And we want to make sure that the geological barrier remains intact. So a lot of our investigations currently, in anticipation of the general license, focus on this work to understand how these gullies are formed. We actually dating a lot of terraces and the valleys in northern Switzerland. We try to understand the past evolution, the extent of the ice age and the flow systems, and this all goes into a sensitivity analysis to estimate how likely it is that new gullies will form or old gullies will be over-deepened again in future ice ages. So in all this work which is being done up to the general license, our URLs play an important role, and I want to spend some time on that as well. One of these URLs is the Grimsel test site. It is an international laboratory. It's high up in the mountains. It used to be, the focus used to be the investigation of granitic rock. Now, as the program has shifted at NAGRA from granitic host rock to clay host rock, also the focus for NAGRA at Grimsel test site has shifted. This doesn't mean, however, that we still do a lot of other experiments there based with international consortia and partners. What we currently do for NAGRA's purpose at the Grimsel test site is looking at the behavior of EBS components, heat generation, gas, and also trying to look at new materials. Furthermore, the GTS is very important for international collaboration, us training, and also communication with the various stakeholders. Next to the Grimsel test site, we have the Monterrey URL, which is located in northern Switzerland. This URL is located in the opalines clay. It's the same host rock, but it's less deep, and it also has a different tectonic overprint as the opalines host rock, as the opalines clay at the selected site. So it's the same type of rock, but it's slightly different. So we did a lot of investigations in the past in the Monterrey URL, characterizing the clay, the chemical behavior, and build up the whole knowledge of the opalines clay in the Monterrey URL. We've tested our models there, the databases also for radionuclide migration. The whole THMC understanding was developed there. Now, what we do now, as we have the site investigation program at the selected sites, the rock characterization is shifting to the selected sites. And the Monterrey lab is mainly used for longer term experiments and testing specific aspects. So this was like the short-term RD&D perspectives. up to 24 when we hand in the general license and the updated safety case. Now look a bit further to the longer term RD&D perspectives. We still have a long road ahead of us. This is the NAGRA roadmap for repository implementation until return to Greenfield, which will go beyond 2100. A lot of activities are lined up, and the red line is where we currently are. So what does it mean for our RD&D activities? Basically, in the blue box, you see what we're doing now. We have the generic rock laboratories, Monterrey, and the Grimsel test site, where we do our experiments, also surface laboratories and modeling. This will feed into the general license. Once we have selected the site, we will construct a rock laboratory at the selected site in one of the 3 sites in northern Switzerland. And there we will confirm the behavior and the models and the whole expected repository description at these selected sites with additional confirmation experiments and investigations. And an update of the safety case will take place. So these are the drivers of the RD&D program. The general license, which I explained in quite a bit of detail, the construction license, which will come in 2050 with an updated full safety case, performance confirmation, and detailed design of the full repository, and then the operating license around 2055. So what are we going to do up to the construction license? So then at that time, we will do the final selection of the barrier materials and concepts, the optimization of the repository architecture, fulfilling the detailed design requirements, including technology development, the whole equipment to emplace the waste, to take it to show that retrieval is possible, the optimization of the methodologies and concepts, and the performance confirmation in the rock laboratory at the selected site. We don't have pictures from that now, of course, because we're talking about 15, 20 years in the future. But here you see some pictures from the ongoing hot band experiment at Grimsel test site. And then operating license, which will come even more after that. Then we'll finalize the technology development and the optimization for operation. And we will also do the demonstration experiments. Demonstration that you actually, with the developed technology, can emplace the waste using remote handling and take it also back out. Here are also a couple of pictures from the hotbed to illustrate the size of the operations. So what are the main messages for the upcoming NAGRA RD&D plan? So we have a 5-year cycle for producing RD&D plans. The next one is due in 2021, and we are already working very hard on it in order to get it ready. Currently, the first main focus is the bulk of the RD&D program is currently focusing on the final inputs to be delivered for the submission of the general license. These contribute to the argumentation for the selected site, one of the 3, the update for the safety case, and the conceptual design of the repository. A group of activities already focus on optimization, which will occur after submission of the general license application. This can be thermal optimization, component alternatives, canister alternatives, for example, but also methods for evaluation of optimization opportunities. In the future, we expect that these optimization activities will increase, while the RD&D supporting the license will come to completion in order to finalize the documentation for the license. This brings then me to the conclusions and shows that while the NAGRA program is now in the site selection, with the general license application coming close, different programs, and you see here various European programs, are in different stages. Although different programs are in different stages, this still means that there is a lot of common interest in doing RD&D activities together. And this is what I would like to close this presentation with, because international collaboration is of capital importance. Thank you for your attention.
Well, that was a presentation by the Dr. Irina Gauss from the Swiss NAGRA, and while she talked about the research and development plan for the management of the high-level radioactive waste, it was very nice.
Now we have the last presentation for this session from Finland, Posiva, under the topic of the evolution from R&D organization to an implementing organization.
My name is Tiina Jalanen, and I'm the Development Director in Posiva Oy. I would like to tell you about safe final disposal of spent nuclear fuel in Finland. Here you see illustration of our different roles in waste management. We have two producers of nuclear energy, Teollisuuden Voima and Fortum Power and Heat. And they take care of their municipal waste, recyclable waste, and also the low and intermediate level waste in their own repositories at the nuclear power plant sites. And they have founded Posiva Oy to take care of the final disposal of spent nuclear fuel. And right now, the spent nuclear fuel that these operators have produced is in interim storage of spent nuclear fuel. In Posiva, here you see an illustration of our encapsulation plant and the final disposal facility. So we have a solution for the final disposal of spent nuclear fuel. We also play a significant role in climate protection as part of the life cycle of sustainable nuclear energy. And I will tell you some more about our final disposal concept and our facilities. Posiva was established in 1995, and as said, our mission is final disposal of spent nuclear fuel for our owners, and also we do other nuclear waste management expertise tasks. We are owned by Teollisuuden Voima with 60% and Fortum Power and Heat 40% of Posiva. And at Posiva, there are approximately 90 employees. And in addition, we make use of the expertise of our mother company, TVO Group, in our operations. Last year, our turnover was 81.8 million euros. And Posiva's subsidiary, Posiva Solutions Oy, is focusing on the service business, and it was established in 2016. Posiva Solutions offers customized expert services together with an extensive partner network. And Posiva places its experience and know-how accumulated on the final disposal of spent fuel at its customers' use through Posiva Solutions. At Posiva, there are several fields of expertise, like from natural sciences, geology, hydrogeology, to project management, licensing, security, and construction. And all this knowledge we offer through Posiva Solutions to our customers' use. The safe final disposal will be started first in the world in Onkalo. But before this, we have done 40 years of work to prepare for this. The site investigations, the selection of the site and the concept has been started already in the 1980s. We selected the site of Olkiluoto to host the final disposal facility in 2000. We applied for construction license for the final disposal facility 2012, and we are about to submit the application for operating license 2021, end of next year. Right now, we are constructing the encapsulation plant and the final disposal facility, preparing for the operations, and we plan to start the operations in the mid of 2020. As we start the operations, there will be 100 years of project ahead of us, since together with the operating time of the nuclear power plants and the cooling time of the spent nuclear fuel, it takes about 100 years to be able to do the final disposal of the last spent fuel from our owners. And after we have done the final disposal operations, we will close the final disposal facility, and we plan to do it in 2120, so about 100 years from now. And here you see the safe and efficient final disposal concept we are operating in Olkiluoto. The host rock is giving us good properties in the depth of 500 meters. And the final disposal concept has the canister where the spent nuclear fuel will be enclosed, and it is surrounded by buffer in the disposal hole, and the deposition tunnels will be backfilled with expanding clay. We will build the deposition tunnels along with the disposal operations so that there will be a few disposal tunnels ahead of the operations constructed. We have developed the engineered barriers, the canister, the buffer, the backfilling, and the closure solution for all the rooms in the final disposal facility since more than 30 years now. We have done site investigations and now are doing site confirmation studies and site description modeling. And we have developed the equipment to be used in the final disposal operations underground. We also have developed the construction methods to be able to construct the deposition tunnels according to their requirements. Since 2004, we have investigated the bedrock of Olkiluoto in great detail. We started the construction of Onkalo 2004, and during the construction, constructing the ramp, shafts, and other rooms in the disposal level, we developed also rock construction methods, implemented tens of tests and demonstrations in Onkalo, and we have drilled dozens of test holes above ground and underground. And in the picture, you see the grayish ramp and the shafts that already are there and have been constructed. The greenish area is under construction. Most of it has already been constructed. And the red tunnels will be constructed as the first part of the final disposal facility. And then, as said, the other deposition tunnels will be constructed along with the disposal operations proceed. And right now there are approximately 6.5 kilometers of excavated access tunnels and vehicle accesses in Onkalo. We also have demonstration facilities where we have done several part scale and full scale demonstrations. And then we have technical rooms at the level of 437 meters below ground level to host vehicles and other equipment in the final disposal facility underground. We also have demonstration facilities above ground, and then here you see the inlet air center in Onkalo on the left of the picture. In the middle of the picture, you can see the machine to bore the deposition holes in the floor of the tunnel. So this machine is a prototype machine, but the same kind of a machine is under construction and will bore the holes to each canister that will be disposed of in Onkalo. And also on the right of the picture, you can see a deposition hole that has been constructed as a demonstration, and also the demonstration tunnel to show that we can construct them according to their requirements. In this picture, you can see as-built measuring in Onkalo in the area of technical rooms at the level of 437 meters. So these technical rooms are much wider in the dimensions than the actual deposition tunnels. To start the final disposal of spent nuclear fuel as the first in the world, Posiva has launched an ECA project. An ECA project will consist all the operations that are needed to submit the operating license application, to construct the facilities to be ready for operations, and also to do all the licensing that is needed for such a nuclear facility. So it consists the construction, equipping, and commissioning of the encapsulation plant that you see an illustration picture. Technical equipping of the disposal facility, excavation of the central tunnels, and the first 5 deposition tunnels will be built in this ECA project. And underground operation equipment will also be built, and canisters and bentonite components compliant with the requirements for the first deposition tunnel. The whole operating license process is included in our project, and also the activities to prepare to start the production in 1 deposition tunnel. And here you can see the operation principle of the encapsulation plant. So number 1 is the area where the spent fuel cask is received, and there is also the storage of the transport cask. The transport cask will be lowered down to meet the canisters in the fuel handling cell number 2, and there the spent nuclear fuel will be lifted from the transportation cask, dried, and encapsulated in the final disposal canister. Then the canister will be lowered down to the rails and moved to the measurement station, where we will measure the surface contamination and we'll do cleaning if needed. And we also do the welding, machining, and inspecting of the copper lid. Then the canister will move along the rails again to the station number 4, reception and storage of empty deposition canisters. No, sorry, not empty canisters, but the disposed canisters and closed canisters. And then to the canister lift, which is right above the final disposal facility, and the canister will be lowered down to the final disposal facility via a lift and through the shaft all the way down to wait for the final disposal. We will gather all together the canisters of 1 deposition tunnel before we start the final disposal in the tunnel, and that is 35 to 40 canisters approximately according to the host rock properties. And here you see the visualization of the encapsulation plant in Olkiluoto and the Onkalo site. So right below this encapsulation plant, we have the final disposal facility under construction. And this is how the construction site of the encapsulation plant looks about today. So we are about 10 meters above ground level right now, and we are constructing the level where we move the canister and the transportation cask of the spent fuel. So we will aim at finishing the construction in 2022 and then prepare for the operations further on from that. And right below that encapsulation plant, we have construction work at Onkalo continuing. So we will have access tunnels and vehicle access 6.5 kilometers incomplete, technical rooms in the level of 437 meters. We will equip the personnel shaft, and the reinforcing of the canister shaft is ongoing. We have the inlet and exhaust air shafts, canister receiving station and storage, and access to the repository tunnels. And the vehicle access tunnels, we have approximately 1.5 kilometers, and central tunnels right now approximately 600 meters. And we will build the deposition tunnels, the first 5 of them, and each of them are about 350 meters long. And we will also construct the deposition holes of the first deposition tunnel. And the first deposition tunnel is the lowest one of the red tunnels, as seen in the picture. There are also ongoing other construction works like the heating, ventilation, and air conditioning works at Onkalo. So we will do this along with the construction of the tunnels. And here you see a picture of the technical rooms level and see that the construction is ongoing there. We are building there also social rooms and office facilities underground. And this is about how the disposal facility will look like in 2120, as we have constructed all the deposition tunnels. They host all the canisters, and then we are ready to close the final disposal facility. This final disposal facility has a capacity for about 6,500 tons of uranium, which is about 3,250 canisters. And the construction time and service life for the disposal facility is about 100 years. The volume totally of the repository is approximately 1.5 million cubic meters. And altogether, once we have finished the operations, the length of the tunnels is about 50 kilometers. And the statement of the Finnish Radiation and Nuclear Safety Authorities took regarding the construction license of Posiva says the disposal facility will remain safe without external actions once it has been closed off. So it is a passive system, no guarding or any activities are needed after the closure of the final disposal facility. And here you see an illustration of the repository as it looks right now in the left upper picture. And then below that, you see that all the facilities above ground have been decommissioned. So there are no more facilities and it is left as it as a passive system. And we will do evaluations how the nature will look like and what kind of events there will be in Olkiluoto Island for 4,000 years and even for 100,000 years. And our safety case goes all the way to several hundred thousands of years to evaluate how the system behaves. And with all that documentation, we have our safety case showing that the final disposal is safe. Thank you. With this picture, I thank you for your attention.
Well, we thank you for sharing very insightful and important information. Now we have covered Spain, Switzerland, and Finland. This is where we wrap up this session, and we will be back at 4:10. We will take a quick break, and we will continue to meet and share cases from abroad. We will have 3 more presentations, and then we will have a panel discussion session. All right, maybe you feel a little bit tired. Now we will take a break, and then we will be back at 4.
2020년
국내의 안전하고 발전적인 미래를
방사선 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 포라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사능 폐기물 안전관리 국제 심포지움 개최를 축하드립니다. 국가, 안전, 환경 모두가 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다. 앞으로도 미래 세대를 위해 힘써주세요. 화이팅! 화이팅!
방사성 폐기물 안전관리 심포지엄 화이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사성 폐기물 안전관리 심포지엄에서 방사성 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사성 폐기물의 안전한 관리를 위해 항상 힘써주셔서 감사합니다. 한국원자력환경공단 응원합니다.
국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
안전한 날만 따뜻해주세요. 또요.
코로나 속에서도 화이팅!
대한민국의 에너지를 책임지고 있는 원자력. 원자력 에너지 이용 과정에서 발생하는 방사성 폐기물 안정성에 대한 불안과 갈등은 계속되고 있습니다.
방사성 폐기물 관리에 대한 인식이 좀 우려스러운 우려를 또 할 수 있습니다.
신뢰받는 안전한 처분 시설, 건강하고 깨끗한 미래를 만들기 위한 노력은 선택이 아닌 필수가 되었습니다. 원전 수입국에서 원전 수출국으로 자리매김하며 세계 최고의 원전 기술을 자랑하고 있는 대한민국. 인정받고 있는 우수한 기술과 안정성에는 원전의 부산물인 방사성 폐기물에 대한 안전한 관리가 뒷받침되었습니다. 책임 있는 방사성 폐기물 관리를 위해 중저준위 방사성 폐기물을 안전하게 처분할 처분 시설과 안전한 운송을 위한 방사성 폐기물 해상 운반 전용 선박 등 관리 기반을 갖추었습니다. 또한 인수, 운반, 저장, 처분을 하는 전 과정은 엄격한 기준과 안전한 설비를 통해 이루어지고 있으며 치밀한 원격 추적 관리로 안전성을 높이고 있습니다. 대한민국은 지금 국민의 안전을 최우선으로 하는 안전하고 깨끗한 에너지 전환 시대를 맞이하고 있습니다. 국가 에너지 정책 패러다임을 전환하는 과정에서의 최우선 과제는 바로 사용 후 핵연료 관리, 즉 고준위 방사성 폐기물 관리 사업의 기반 조성과 처분 기술의 개발은 한국원자력환경공단의 중요한 과제가 되었습니다. 최고의 안전성으로 신뢰받기 위해 노력하고 있는 한국원자력환경공단. 에너지 전환 시대를 한 발 앞서 나간다는 사명감을 가지고 방사성 폐기물의 안전하고 효율적인 관리를 통해 국민 생활의 안전과 환경을 지켜나갈 것입니다. 지속적인 기술 개발을 통해 안전한 관리에 필요한 추진 기반 구축과 핵심 기술을 확보하고 신뢰할 수 있는 관리 정책을 실현시키기 위해 노력하겠습니다. 다음 세대를 위한 깨끗한 환경, 행복한 미래. 안전으로 신뢰받는 국민의 코라드. 한국원자력환경공단이 만들어갑니다.
안전하고 발전적인 미래를
방사선 폐기물의 안전한 관리를 위해
2020년 코로나 속에서도 온라인 개최를 통해서 방사선 안전관리에 힘써주신 여러분께 정말 감사드립니다. 성공적인 행사가 될 수 있도록 저도 응원하겠습니다.
안녕하세요. 이번 국제 심포지엄을 통해서 방사선 폐기물 관리 기술 개발을 모색할 수 있는 자리가 마련돼서 너무 좋습니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄 파이팅!
사람 프로젝트는 사랑입니다. 포라드 제7차 방사성 폐기물 안전관리 국제 심포지엄 성공적인 개최를 응원합니다.
방사능 폐기물 안전관리 국제 심포지엄 개최를 축하드립니다. 국가 안전, 환경 모두가 성공할 수 있는 방사능 폐기물 안전관리 응원해요.
제7차 방사성 폐기물 안전관리 국제 심포지엄을 응원합니다.
안전한 우리들의 미래를 위해 노력해 주셔서 감사합니다. 앞으로도 미래 세대를 위해 힘써주세요. 화이팅! 화이팅!
방사선 폐기물 안전관리 심포지엄 화이팅!
제7차 방사선 폐기물 안전관리 국제 심포지엄이 코로나 상황에서도 무사히 진행되기를 기원합니다.
제7차 방사선 폐기물 안전관리 심포지엄에서 방사선 폐기물 안전성 확보를 위한 방안이 꼭 모색될 수 있기를 기대합니다.
방사선 폐기물의 안전한 관리를 위해 항상 힘써 주셔서 감사합니다. 한국원자력환경공단 응원합니다.
국내의 안전하고 발전적인 미래를 위해 열리는 제7차 방사선 폐기물 안전관리 국제 심포지엄 화이팅!
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공 개최를 기원합니다. 응원합니다.
제7차 방사성 폐기물 안전관리 국제 심포지엄의 성공적인 개최를 응원합니다.
안전한 날밤 스타트해주세요. 또디야.
코로나 속에서도 화이팅!
So with you, we are having this very intensive and in-depth seminar and presentation of this seminar and symposium, and various valuable trends and information of the overseas and the technology and everything related to these industries are being dealt with by the speakers. And we are heading to the final session today. And after this session, we're going to have further in-depth discussions. And before we begin the next session, we would like to just check if you had any questions and a Q&A chat quizzes and answers. And also, now we're going to invite the international speakers for the presentation, and then we're going to have a panel discussions. Well, we're going to invite Dr. David Sassani from SNL to hear about the 5-year plans for spent fuel and waste science. Please welcome him.
Good day to everybody. I'm David Sassani of the Sandia National Laboratories. I'm the National Technical Director for the Spent Fuel and Waste Science and Technology Campaign of the U.S. Department of Energy. My background is as a geologist geochemist classically trained, and I started working in 1993 on the U.S. Yucca Mountain project in the performance assessment department, doing incorporation and development of models of the geochemistry and geochemical interactions between the natural system and the engineered barrier system and the source term at Yucca Mountain. I was part of the team that's helped put together the bases for the license application that was submitted by the Department of Energy to the Nuclear Regulatory Commission in 2008. And since about 2010, I've been working on this campaign, the SFWST campaign. And what I'm here to talk to you about today is part of that campaign's work, which covers storage of spent fuel, transportation, and also disposal of radioactive waste. And today I'm going to give you an overview of the 5-year plan for spent fuel and waste science and technology campaign disposal research. So today I'll give you a little introduction to the program planning aspects, an overview and some of the challenges we face, and talk to some of the completed prioritization efforts from the past work and what our disposal research program covers. Then I'll cover the disposal research 5-year plan in detail, giving you some purpose and structure of the plan. The priorities, I'll go through those in detail, and then I'll give you an integration example from our recently completed fiscal year 21 planning, and then I'll conclude my talk. So the objectives of our disposal research program for generic disposal concepts are here, which is to provide a sound technical basis for multiple viable disposal options in the United States. That includes spent nuclear fuel disposal, commercial and DOE managed, and high-level nuclear waste glass disposal. We also have an objective to increase the confidence in the robustness of the generic disposal concepts that we investigate, and to develop the science and engineering tools needed to implement and support those disposal concepts. Here's 3 examples of various disposal concepts from the international world. There's a salt repository shown from Gorleben, Germany, an argillite shale repository example from Meuse-Haute-Marne, France, and a crystalline repository example from Forsmark, Sweden. And this uses their KBS3 engineered barrier development design. Well, what are the challenges that we face in the program for prioritization? Well, first is we're looking at a wide range of geologic disposal concepts, not just a single one. We're also trying to constrain the generic R&D that's most important for each of those. And defining when that generic R&D is complete enough is a little bit of a challenge. And then we have a challenge of dealing and incorporating the vast international experience that exists out there, which we're very thankful for, and then to integrate the cross-cutting aspects for things like engineered barrier systems clearly across these concepts. So for planning and prioritization within our disposal research program, there are things like program direction, which is technical direction from the Department of Energy, and also funding direction from congressional appropriations. There's the generic nature of our studies, which means they are very broad, and we have to develop capabilities for safety assessments in multiple geologic disposal concepts. The international investigations cover a large range of material, including very site-specific work that informs our generic R&D very well. We've completed a couple prioritization efforts on the program, one in 2012, which became a roadmap to our research and development work in our campaign, and one in 2019, which was an update to that roadmap, which started with fiscal year 17 reassessment of how much we've completed, where we are, and what our new priorities are. And that's all resulted in our fiscal year 20 coverage of disposal research in the 3 host rock areas shown here, but also in cross-cutting areas here for things like the safety assessment work, but also for dual-purpose canisters, which are large storage and transportation canisters that have there's about 3,000 of them in dry storage currently loaded with like up to 32 pressurized water reactor fuel bundles in them. So we're looking at those specifically. So each of these areas cross-cuts the various host rocks. So I'm now going to move on to an introduction of the actual 5-year plan that we've put together. So our 5-year plan for disposal research is shown here as a shot of the cover page right there. Its purpose and utility are to be a strategic guide to the work within our technical areas, those control accounts that I showed you just previously. And it's concise and put together to provide the thrust topics in each disposal research technical area. And it's planned to be a living document that's updated annually based on things like program direction, technical progress within our work, and our enhanced understanding and knowledge of each of these generic disposal systems. It's structured around thrust topics in each disposal research technical area for both the near term, which is about 1 to 2 years and is our present portfolio with modest modifications over that time frame, and the longer term, which is 3 to 5 years, which really gives us a vision of where the disposal research is heading, barring any kind of major program changes. It's implemented by executing the work and revising the plan each year. And the first revision that we do coming up this next fiscal year will add reports on progress for the short-term thrust areas and provide the bases for any revised prioritization of the work. So I'm showing here the argillite disposal R&D technical area. And the first bullet shows the near-term thrust topics. And I'll remind folks that these are the thrusts, the focus areas for the next 1 to 2 year period. And one of them that I've highlighted here is the coupled thermal, hydrologic, mechanical, and chemical processes, and getting after those in particular as they affect the repository performance. Then in terms of longer term thrust topics, which are the next 3 to 5 year period after the near term, one of the big focuses will be on the field testing on an international scale, and including that process understanding and revisions to the models. The next technical area is the crystalline disposal R&D, and the near-term thrust I'm highlighting here for that are transport and fractures, and including matrix diffusion in the host rock between the fractures. In terms of a longer-term thrust, performance of the candidate buffer materials under a range of disposal conditions, as the engineered barrier is quite important for performance in a crystalline disposal system that has fast fracture flow. That's our longer term thrust here. On this slide, I'm showing the third host rock technical area, salt disposal R&D. And in the near term, the real focus is heat generating waste and its effect on the host salt that it's in. And we're running what's called the brine availability test in salt, or BATS, currently a horizontal borehole heated test in the waste isolation pilot plant Permian Salt in Carlsbad, New Mexico. In the longer term thrust area, integration of the models for the salt behavior into the safety assessment framework is going to go on in the 5-year time frame. For the safety assessment itself, near-term thrust topics include things like enhanced uncertainty and sensitivity analysis and detailed repository systems analyses. We've been demonstrating our capabilities in this area throughout the program in multiple geologic repository concepts for generic systems, and this will continue to be a focus. In terms of the longer-term thrust in this safety assessment area, will be models from the host rock investigations incorporating more detailed processes into the geologic disposal safety assessment. This next technical area that I'll speak to is the direct disposal of dual-purpose canisters. These dual-purpose canisters, numbering about 3,000, have been loaded for about the last 20 years. There's a timeline shown here from the center of the circle outward, and this is 2020, currently right here. The next concentric circle is out to 2030, and then the next one is when the total spent nuclear fuel are in dry storage canisters. So this is the future time frame here. What I can show you is that each of the wedges refers to various activities that we're doing, listed here in the thrust topics. So we're doing criticality consequence analysis of existing dual-purpose canisters and future ones, and that includes looking at reactivity margins as well. We're also evaluating the injectable fillers for various types of dual-purpose canisters using either cements or molten materials to inject to reduce the reactivity and the potential for criticality over time in a geologic system. Lastly, for future dual-purpose canisters, we're looking at things like modifications to the fuel, shown here, or basket redesign, shown here. Longer-term thrusts include demonstration of these injectable filler materials to reduce the potential for criticality. Here in this slide, the technical area that I'm speaking to and its thrust topics is the international collaboration in disposal research. And this diagram shows kind of pie wedges that indicate the various host rocks, argillite/mudstone, salt host rock, and crystalline host rock. And then the countries that we're collaborating with are indicated, and where within the host rock versus the engineered barrier system the activities are located physically and what their focuses are. I won't speak to that anymore, but one of our near-term thrust is constantly looking for new international opportunities, but we are also pursuing more active role in conducting experimental work in the international underground research laboratories themselves. As a longer-term thrust, we're working to develop best practices and technologies for site selection, which is far off from the R&D being done currently in our generic propository programs. Moving forward to the next slide, I'm going to cover the engineered barrier system R&D thrust topics. And particularly what we're focused on in the short term is the bentonite buffer drying and resaturation processes. That is the thermal hydrologic behavior of the bentonite buffer. In a longer term thrust, we're looking to incorporate from the underground research studies in the international area the EBS performance and design materials, for example, the cement behavior in a system. The next technical area is the online waste library, a database on inventories that we've put together and some waste characterization work we've been performing. And our near-term thrust on that for the database is developing the change control and release control processes for versions of the online waste library database. On a longer-term thrust, we're considering building in additional interface capabilities for the safety assessment framework directly from this inventory database. So on this last slide of the technical area thrust topics from the 5-year plan, we're looking here at the underground research laboratory activities that we've started up last year. And one of the near-term thrusts is to put in place a passive monitoring system for ambient gases in this unsaturated system. In terms of longer-term thrust, the long-term data collection from that monitoring system as well as potential cosmic radiation detection will be going forward. Lastly is the knowledge management area, which is in the campaign management control account, which is above the disposal research area, but it's focused, this knowledge management activity, mostly on disposal research to this point, so it's in the 5-year plan. And one of its near-term thrusts is to expand the topical coverage for the disposal program and into the storage and transportation R&D areas. In the longer term, the efficacy of this knowledge management repository, we want to expand to larger portions of the nuclear energy fuel cycle community. Okay, so I finished covering what was in the 5-year plan for the technical areas. And what I'm moving on to now is an example of an update that we created in our fiscal year 21 planning that just occurred at the end of September, beginning of October. And here is the structure that I showed you previously for disposal research under the SFWST campaign for fiscal year 20. And what I want to speak to here in a couple of slides is to tell you about some integration work we did, which took 9 activities of the technical nature that were scattered across 6 of these technical areas and pulled those together and collated them into a single area here, named slightly different as inventory and wasteform characteristics and performance for our fiscal year 21 structure. So I'll go on and give you more details now about what that entails. So now I'm moving on to some changes we made in our fiscal year 21 planning, where we updated the campaign structure a little bit, and it was for integration within the disposal research for our waste forms work, and particularly some developments we're doing in planning testing on spent nuclear fuel. So down here you'll see the inventory and waste form characteristics and performance technical area, and it's up here again as shown. And you can now see the sub-activities. Previously for FY20, only one sub-activity existed, which was covering the inventory work in our online waste library development with some waste form characteristics aspects as well. But because we had a number of activities across 6 of these different technical areas, which were developing either models for spent nuclear fuel degradation or helping to plan some of the testing or characterizing that, the fuel itself or the cladding, we integrated all of those activities under this one umbrella so that we would have better and more efficient work going on between these different technical areas. So going forward now, this structure provides us a better integration platform for finishing the development of the test planning and actually starting the testing. And you can see a number of national laboratories, including Sandia, Argonne, Los Alamos, Pacific Northwest, and Oak Ridge National Laboratory are all involved in this. This slide is a visual depiction of our disposal, R&D, host rock, and cross-cutting activities. And the 3 different host rock investigation areas, argillite, crystalline, and salt, are shown here, argillite, crystalline, and salt, as wedges of this pie diagram. And then the cross-cutting activities are shown as concentric circles or rings, with the international at the center, the engineered barrier here next, and these apply to all 3 host rock types. And then the dual purpose canister area, which I spoke to, shaded in green for where it applies mostly and fading into the host rock color where it does not apply very much. And what I just covered in terms of the inventory and waste form area, our S&F testing in both crystalline and argillite fluids is just the newest cross-cutting activity that we've put on here. So in summary, our generic disposal research, R&D planning, and prioritization is driven in multiple ways, from program direction, the generic nature of our studies, focusing on safety assessment capabilities, and incorporating international investigations. Within our campaign, we completed 2 detailed planning prioritization activities, the 2012 roadmap and then the 2019 roadmap update. Both of these have informed in our development of the disposal research 5-year plan for our R&D priorities, both in the near term, 1 to 2 years, and the longer term vision of where it's going in 3 to 5 years. Our work is to develop that material and to integrate the technical thrust areas within our campaign and with the storage and transportation work and beyond to the whole waste management community. Thank you so much for your time and attention. This concludes my presentation.
Well, for the next 5 years, we have heard their plan for the next 5 years, and we could imagine the realization of the plan. And that was Dr. Sassini. And now we're going to invite the Dr. Fulpani from the SNL.
And under the topic of development and analysis of repository reference case simulations using P-Flow, Fortran, and Dakota.
Hello. My name is Paul Mariner, and I work for Sandia National Laboratories. In this presentation, I will talk about a project I have been working on for the past 8 years, the development and analysis of repository reference case simulations using P-Flowtran and Dakota. Sandia is a United States national laboratory located in Albuquerque, New Mexico. My research team at Sandia serves the United States Department of Energy, Office of Nuclear Energy. The team's focus is Geologic Disposal Safety Assessment, or GDSA for short. The scope of our work is to develop a disposal system modeling capability for deep geologic repositories, including uncertainty. The motivation for this work is to maintain and further develop state-of-the-art capability for performance assessment of a future potential repository. The performance assessment capability we are developing is called GDSA Framework. It is a framework of core codes, databases, preprocessors, and post-processors. The core mechanistic code is pFlowTran. pFlowTran is a multiphysics simulation and integration code. It simulates important features and processes in the model domain from the source term through the repository and geosphere to the biosphere. The core uncertainty quantification code in GDSA framework is Dakota. Dakota is used to generate multiple realizations to propagate uncertainty, calculate confidence intervals, and perform sensitivity analyses to assess the importance of various inputs and their uncertainties. Some of the other codes we use as a part of GDSA framework include Python, DFNWorks, and Paraview. Basic requirements of GDSA framework include that it interface with our geologic framework models, it apply uncertainty quantification and sensitivity analysis methods, it leverage high-performance computing resources, and it be open source. Using GDSA framework, we are developing a set of total system reference cases for different potential host rocks and various repository designs. So far, we have developed reference cases for argillite or shale, crystalline rock, bedded salt, and unsaturated alluvium. We also have some variations on these reference cases having to do with the spacing of waste packages, the number of assemblies per waste package, and placement of the waste packages, whether in drift or in boreholes in the floors or the walls of the tunnels. pFlowTran is a THC code. That is, it can simulate the flow of energy and groundwater while also simulating chemical reactive transport. pFlowTran can simulate both multi-phase and multi-component subsurface systems. To do all of these things well in high resolution, pFlowTran must be massively parallel, which it is. While massively parallel, pFlowTran can also be run on a laptop. pFlowTran has been around for more than a decade. Our disposal research program at Sandia adopted it in 2013 because of its THC capabilities, also because of its high-performance computing capabilities and the fact that it is open source. Currently, pFlowTran is in the process of being adopted by WIPP in Carlsbad, New Mexico, for recertification activities. The United States has been disposing of low-level and transuranic waste at WIPP since 1999. pFlowTran has also been applied to planned repositories in other countries. For example, pFlowTran was used to simulate sulfide production, reactive transport, and copper canister corrosion for the repository designs of Sweden and Finland. Much use of pFlowTran has also been in environmental applications, such as the hexavalent uranium plume at Hanford, shown in the figure at the right, and in carbon dioxide sequestration. As mentioned before, pFlowTran is open source. It is also freely available at pflowtran.org. We think these accessibility attributes will allow for enhanced adoption, collaboration, development, and testing of pFlowTran worldwide. We continue to develop the source term models of pFlowTran for simulating waste package degradation, waste form degradation, and radionuclide release. Currently, we have reduced order models for simulating waste package breach, including a corrosion model that is temperature dependent. More sophisticated models are under development, such as a copper corrosion model and a cladding degradation model. Our source term models include an instantaneous release fraction model, several types of waste form degradation models, and a fuel matrix degradation model that considers radiolysis, mixed potentials, the buildup of a corrosion layer on the fuel surface, and diffusion through the corrosion layer. Radionuclide decay and ingrowth is simulated at all times, within the waste package and after release. Beyond the source term, pFlowTran's capabilities for simulating repository systems has been enhanced by the implementation of isotope partitioning and solubility models, radionuclide decay and ingrowth in the flow and transport domain, mapping of discrete fracture networks to an equivalent continuous porous medium, buffer and disturbed rock zone porosity and permeability evolution, as depicted in the figure, temperature-dependent thermal conductivity, a well water ingestion dose rate model, and other models. Models under development include temperature-dependent solubility, dynamic adsorption, improved colloids models, copper corrosion, an advanced biosphere model, and advanced capabilities in meshing and sensitivity analysis. Dakota is also an open source code that is freely available. It is used for optimization, uncertainty quantification, parameter estimation, and sensitivity analysis. In GDSA framework, Dakota is used to perform random sampling or Latin hypercube sampling of uncertain input parameters. Dakota is also used for statistical analyses and sensitivity and variance analyses of the relationships between inputs and outputs. For the remainder of this presentation, I will describe the probabilistic application of GDSA framework to one of our crystalline repository reference cases. The domain of our crystalline repository reference case is 3 kilometers long, 2 kilometers wide, and 1.3 kilometers deep. This figure shows a cutaway of only those cells containing fractures or enhanced permeability. You can see the full repository in the left center of the figure. The repository itself is more finely meshed than the host rock. The vicinity of the repository uses 1.67 million grid cells. There are 5 deterministic fracture zones. 2 are in red and the other 3 are subvertical and appear faintly in gray. These 5 fracture zones are included in each realization. The discrete fracture networks, or DFNs, are stochastically generated using a code called DFNworks. The general properties of these discrete fracture networks are based on the Forsmark datasets. As at Forsmark, fracture density decreases with depth. The DFN fractures are mapped to the mesh, assigning an equivalent porosity and a permeability tensor in the X, Y, and Z directions to each grid cell. Not shown in this figure is a 15-meter thick glacial aquifer at the top of the domain. Flow is generally from left to right. There are nearly 5 million grid cells in all. Here is a closer look at the simulated repository. The top figure shows a vertical cross-section of the 3 drifts. The red cells are waste packages. The light blue cells are buffer, and the darker blue cells simulate the disturbed rock zone, or DRZ. The bottom figure shows a plan view of the entire repository, and if the figure is clear enough for you to see, it shows each waste package in the repository. In this design, we have in each drift 80 12 PWR waste packages for a total of 3,360 waste packages in the entire repository. In this reference case, we simulate heat generation from the waste packages and from the Earth's interior, flow of groundwater and heat, general corrosion of waste packages, instantaneous release of 10% of the iodine-129 in a waste package upon waste package breach, waste form degradation, and advection and dispersion of iodine-129. No other radionuclides are considered in this analysis. The general corrosion rate is a simple Arrhenius equation, and as such, it is temperature dependent. The coefficient R is the corrosion rate at 60 degrees Celsius. This coefficient is allowed to vary among waste packages within a single realization according to a mean and standard deviation sampled for the realization. In addition, the mean and standard deviation of R is uncertain among realizations. In other words, not only does the waste package corrosion rate vary spatially among all waste packages in a single realization, there is epistemic uncertainty from realization to realization as to what the spatial variability truly is among waste packages. This is a table of all of the uncertainties propagated in this analysis. The first 7, shaded in light green, are considered epistemic parameter uncertainties. They include the fuel degradation rate, the permeabilities of the glacial aquifer, buffer, and DRZ, the porosity of the buffer, and the logarithms of the mean and standard deviation of the waste package general corrosion rate. The final 2 rows, shaded in light blue, are spatially variable uncertainties. They involve the stochastic placement in space of the fractures of the DFNs and the stochastic assignment in space of the uncertain waste package corrosion rate coefficient across all waste packages in a realization. The sampling scheme for this analysis was divided into 2 loops, one in which the epistemic parameters were sampled, the green ones in the previous table, and one in which the spatially variable uncertainties were sampled, the blue ones in the previous table. The spatial variability loop can also be thought of as the DFN loop. A total of 20 spatial or DFN sample sets were generated, and a total of 40 epistemic parameter sample sets were generated. For each of the 20 spatial sample sets, all 40 epistemic parameter sample sets were run, generating a total of 800 realizations. Each realization was run for 1 million years. This is an example of a plume of iodine-129 at some point in time for one of the realizations for DFN1. As you can see, at this time several waste packages have breached, but only 1 or 2 have resulted in iodine-129 being transported into the fracture network of the geosphere. It can be seen from the plume where some of the dominant flowing fractures are. These 2 graphs show the iodine-129 breakthrough curves at 2 of the monitoring points at the top of the host rock, OBS4 and OBS8. The differences in the breakthrough curves at each location indicate the uncertainty in iodine-129 concentration for DFN1 over time, resulting from the uncertainties in epistemic parameter uncertainties. A better indication of repository performance is provided by the peak iodine-129 concentration at potential receptor locations. The peak iodine-129 concentration is a single value for a given realization. Figure 1 shows the cumulative distribution functions, or CDFs, of each of the 20 spatial DFN sample sets for OBS8. Each colored line shows the CDF of the peak iodine-129 concentration across all 40 epistemic parameter sample sets at OBS8. This representation allows us to calculate the mean peak iodine-129 CDF for an observation point considering all epistemic parameter uncertainty. Figure 2 shows the same data, but instead plots the reverse. It plots the CDFs of each of the 40 epistemic parameter sample sets over all 20 spatial DFN sample sets. These graphs indicate that for OBS8, more uncertainty in mean peak iodine-129 concentration is caused by the spatial DFN loop than by the epistemic parameter loop. The results are opposite, however, if we monitor the entire aquifer for peak iodine-129 concentration. Figure 3 shows an aerial view of the iodine-129 plume in one of the realizations at 40,000 years. This figure indicates that we cannot predict, in our reference case, where in the aquifer the peak concentrations will occur because it is a function of where the stochastically generated fractures are located and how they connect to each other and to the repository. For this analysis, we scan the entire aquifer to locate and record the maximum iodine-129 concentration at each time step so that we could determine the spatially independent peak iodine-129 concentration in the aquifer for each realization. What we discovered is that uncertainty in the spatially independent mean peak iodine-129 concentration in the aquifer is due more to epistemic parameter uncertainty than to propagated spatial variability. Which parameters contribute the most to uncertainty in peak iodine-129 concentration is determined through sensitivity analysis. For example, here are scatter plots of the peak iodine-129 concentrations versus epistemic input parameter values. Clearly, the two middle plots show significant correlations with peak iodine-129. Quantities of interest, or QOI, include performance metrics such as peak iodine-129 and other calculatable outputs such as a mean residence time in the repository, flow rate from the crystalline rock to the aquifer, flow rate ratios, and so on. Scatter plots and interaction plots for all of these inputs and quantities of interest can reveal important relationships that might explain system behavior or that might be exploited to enhance waste isolation. The inputs and outputs can be further analyzed using Dakota and its tools for variance-based decomposition. Sobol sensitivity indices can be generated that quantify the relative effect certain inputs and quantities of interest have on outputs such as peak iodine-129. For our crystalline reference case, the largest contributors among input parameters on the variance in spatially independent peak iodine-129 concentration in the aquifer were found to be the permeability of the aquifer and the mean waste package degradation rate. In summary, the U.S. Department of Energy is developing a next-generation repository modeling capability called GDSA Framework. This framework is built around the codes pFlowtran, Dakota, DFNWorks, and other open-source codes. The purpose of this work is to be able to model and assess the performance of geologic repository concepts in different host rocks with uncertainty. We are developing reference case simulations for several host rocks. I focused in this presentation on the crystalline repository reference case and showed how it is advancing and providing valuable insights. We have found that discrete fracture networks can be effectively simulated using an equivalent continuous porous medium. Our probabilistic simulations indicate that uncertainty in peak iodine-129 concentrations in the crystalline reference case can be strongly affected by spatial variability, waste package degradation rate, aquifer permeability, and monitoring location. We continue to work diligently, developing our repository modeling capabilities and reference cases, and will continue to do so for the foreseeable future. It is in our national interest to maintain strong and up-to-date capabilities in this technology and to continue to learn from the good work of others around the world. For this reason, international collaboration is strongly supported by the U.S. Department of Energy. We are always open to new collaborators with similar interests. Now, before I finish, please allow me to briefly show the references for this presentation. And to thank you for your attention.
Well, based on years of studies and researches, and based on the simulations and SNL, once again to share the really important information with us. It will certainly help us develop a further development of the technologies as well. And we have one last presentation from abroad. And that's from Sweden, from SKB, Peter Wickberg, under the topic of R&D main issue of a generic strategy stage for a deep geologic disposal and framework of a risk management for conducting long-term R&D.
Good day, everybody. My name is Peter Wickberg. I'm a senior advisor within the SKB International. And previously, I have been working within the SKB company for almost 30 years. And I'm talking about the initial phases of the SKB program for disposal of spent nuclear fuel. The first phase was the KBS project. Now, KBS in Swedish means nuclear fuel safety. The aim of the project was to show beyond any doubts that the long-lived radioactive waste can be managed safely. And this was a legal requirement from the government in 1977. KBS-1, KBS-2 were desktop study reports that were launched very quickly in 1978 and 1979. The KBS-3 was a full safety assessment based on research and bedrock investigations that included drilling in the rock down to repository depth. Now, this was accepted by the Swedish government in 1984 as basis for future R&D work. After that, the KBS project was transferred into the company SKB, which ever since has been responsible on behalf of nuclear power companies to handle the nuclear waste issues in Sweden. Shortly about the KBS project structure, because the reason for the success of this project was the way it was organized. There was in center project management, keeping everything together. And then there were quite a small group of people with good knowledge about issues of importance for waste disposal. And these in turn, they had their contacts out in the society, in universities, consulting companies, and different kind of organizations. This meant that it was very simple to get the relevant expert for a specific issue that could join all the way from wherever he was to the project management for discussions on how to proceed. Now, the second phase of SKB's program was the RD&D program time. And ever since 1986, SKB has prepared and presented RD&D plans, which actually are a legal requirement also, to be assessed by the regulator and approved by the government. Each plan covers activities for the next 6 years with more details on the first 3 years. This plan is also the basis for calculating or updating the costs for the entire waste disposal system, which actually also is a legal requirement. Now, the SKB R&D programs has been presented every third year from 1986 all the way, and the latest program was 2019, which means that the next one will be 2022. The disciplines for research and technical development actually came up from the need already within the KBS project. And that is related to the special areas of spent fuel dissolution and radionuclide chemistry. Canister both needs research for safety assessment issues and research for manufacturing. Buffer and backfill materials also is both technical development and research. The disciplines of geology, hydrogeology, geochemistry are the things important for the rock, for the disposal site, which need to be handled and from the beginning very much research was needed in order to find out how the rock would behave as a host for the nuclear waste repository. Transport of substances, corrodants to the canister, and eventually radionuclides from the canister to the surface is an area of its own. Surface system, what happens when the nuclides are transported up to the biosphere and they are distributed on the surface, giving those to humans and animals and plants. And last but not the least, climate. What will be the future climate? Glaciations and permafrost issues that have importance for the repository at 500 meters depth. Now, just shortly to describe what is the KBS3 concept's safety barriers. The spent fuel itself has a very slow dissolution rate, which of course is good, but it's not a safety barrier in itself. It provides the source term for the calculations. The first important barrier, safety barrier, it's the canister surrounding the spent fuel, which is inside steel and outside copper. The copper is intended to last as long as there is any dangerous activity left in the fuel. Now the copper is surrounded by the bentonite clay in a deposition hole. And the rock, all the way from repository depth up to surface, will function as a barrier to mitigate the transport of radionuclides in case, for some reason, the canister has been broken. I also want to tell you something about the Espe Hard Rock Laboratory, which is the place where SKB has conducted all research in relation to understanding the processes and conditions of the rock, and also to assess the validity of the models that are used in order to prescribe the conditions of a future repository. We have also developed investigation methods during the time we have carried out this work in Espe. And this has, of course, provided experience and training of staff who has been involved then afterwards in, for instance, the site investigations. And we used the facility to inform both professionals and laymen about how the repository will function in the future. Now the RD&D programs in more detail. The program of 1986 was concentrating quite a lot on the Espe laboratory, which I was just recently talking about, and the plan for that one. The R&D program in 1989 was concentrating on plans for a new long-term safety assessment. At this time, it was already 10 years since the KBS3 safety assessment had been started. And in the RD&D program of 1992, the focus was on planning the repository for spent nuclear fuel in more detail, and also the starting of locating the repository. As you can see, the box in red down here, SKB 91, that was the safety assessment which came out after the work for the next, after the safety assessment work. that was presented in 89. And in this safety assessment, it was obvious that the most importance for safety of the repository is the man-made barriers. But the rock itself is important to give the constant conditions for the engineered barriers. Program 95, encapsulation plant and deep repository project. And also, how should the safety assessment be presented? A scheme for how to report. Actually, that one was ready a couple of years later, which had the name SR97, Safety Assessment, using field data from 3 different sites. And the important outcome of this one was that all of these 3 sites would have met the safety criteria that were put up by the regulator. Now, R&D program 98 presented outcome of the studies on how to locate the repository. The future from 2001 further on is important for developing and research of issues that are still unknown. But the main part of this period was the site investigations, which started in 2002 and continued up to 2008. As a result of these site investigations, we prepared the preliminary long-term safety assessment of a repository for spent nuclear fuel. And also the final report, that was the important material for license application. Now the third phase I'm going to talk about is actually the siting and site investigations, as I mentioned previously. Now in 1992, the siting work was started by asking all municipalities in Sweden whether they were interested to know how a nuclear waste repository would affect them. After completing 8 feasibility studies, SKB selected Östhammar and Oskarshamn municipalities for the investigations. This was in 2001. The candidate sites in the 2 municipalities were Forsmark and Laxemar-Simpevarp. You see it on the map to the right. And the investigation and modeling work started 2002 and ended roughly 2008. Now, during the issues that were of importance was, of course, related to the characteristics of the rock, which would affect the safety. But it also included technology for execution. It included health and environment, and it included societal resources. Now, among these factors, we should come up with what is the best or most suitable location of the repository. It turned out to be the fact that the safety-related site characteristics were different in Forsmark and in Laxemar, which meant that by the end, when we had to select the repository site, it was obvious that that should be Forsmark. We didn't need to consider the technology, execution, societal resources, or health and environment. They were very similar in both locations. Now, during the time the site investigations were ongoing, we had site offices at both locations that were in charge of carrying out all the necessary collection of data used for the that to be used for a safety assessment and for layout work for the repository. We had an organization of roughly 30 people at both locations that were only managing the ongoing investigations. And we kept on investigating constantly during the time that these were running. This was the largest undertaking that SKB had done up to then. And the total cost of the site investigations during this period was 200 million euros. Quite a lot of money, as a matter of fact. Now, in addition to the field investigations of the bedrock and the surface, we also did investigations of the municipalities to find out the current situation and the future development of the society, effects on local and regional economy, impact on labor market, impact on image and tourism for the site that got the repository, spin-offs and synergies, impact on real estate and property prices, impact on health, attitudes, opinions, and acceptance. Also, long-term forecast of demography and businesses. And these investigations were made for comparing what is the role, what is the future of the municipality with the repository and without the repository. SKB was paying for all of these studies, but it was the municipality that got the results and also were the contact to the investigators. And I could add that this work took roughly a third of the time for the entire investigations. For me personally, I was the manager of the investigations in Oskarshamn. The issue which we always tried to keep uppermost were the contacts with the people who were living nearby the repository area, or actually living on the site that might become the repository area. Now the person to the right, the guy in the white sweater was the site manager in Forsmark. His name is Kai Albo. On the next slide, you see to the left Olle Selman, who was the deputy site manager in Oskarshamn. As I told you, the investigations were ongoing up to 2008. In 2009, SKB selected Forsmark to be the location of the repository. And we put in the application for construction permit in 2011. And on the slide here, you see to the right, the nuclear power plants of Forsmark, and to the left, you see the surface facilities of the repository when it has been constructed and is in operation. And on the next slide here, you see what the Forsmark area might look like a few hundred years into the future, say 300 to 500 years into the future, when there is no longer any surface facility that has been taken away and the repository has been sealed. And you can also see to the right, there is no longer any nuclear power plants. But there might be something else, which we of course don't know. But the intention is to leave the surface untouched, and the spent fuel will be safely stored at a depth of 450 meters. Thank you very much for your attention.
Well, thank you very much. So we have concluded all sessions for the international speakers, and for the R&D, current issues were well presented. So for those who are having great interest in the R&Ds and the research, and I believe that this has been very informative for you, and I believe that this was very meaningful so that you can conduct future research.
Okay, then now we will move on to panel discussion, the last program of the symposium. That we will not take a break and just move along. Okay, inviting domestic experts, we will have a panel discussion. Well, we have the chair and panelist. The chair, are you there? The chair for the panel discussion is President Kyung-soo Kim from the KRS. Okay. Can you hear me all right? Let me introduce the panelists. When your name is introduced, please say hello. First of all, from Korea, we have Hwang Taewon Institute, and from KAIRI, we have Mr. Koo Jung-hwae, the Vice President, and we have from KHMP, Mr. Kapok Lee, Chief Researcher, and we have from KTP, we have Mr. Lee, Executive Director. Now, I introduced the four panelists, and once again, Mr. Kyung-soo Kim will serve as chair for the panel discussion. Let me hand over the microphone to Mr. Kim. Thank you very much. Well, once again, my name is Kyung-soo Kim. I'm the president of Korea Radioactive Waste Society, and I am very much delighted to meet you all online at this symposium. And marking the 7th symposium, despite the difficult conditions, we are having a really successful discussions and symposium. And taking this opportunity, I'd like to thank everyone who dedicated their effort for organizing this event. And also, I'd like to thank the four panelists for joining the symposium out of their busy schedule and the difficulties. And as already mentioned before by the MC, let me introduce the panelists more in detail, because regarding the spent nuclear fuel management and technology developments for that, we have various organizations, and we have now the panelists who are taking really big responsibilities in these entities. Therefore, highlighting their importance, I'd like to introduce them once again, because we have a really valuable and distinguished figures here. First of all, regarding the spent nuclear fuel technology development status, we have from Korea Institute head Mr. Taewon Hwang, who introduced the technology development status in the presentation. And second, we have various institutes, and in particular, we have Korea Atomic Energy Research Institute. We have Vice President Mr. Koo Jung-hwae. And next, as a nuclear power operator from Korea Hydro and Nuclear Power, we have a chief researcher, Mr. Kapok Lee. Hello, everyone. Thank you. And last but not least, under the MOT, from the Korea Institute of Energy Technology, Evolution and Planning, we have Executive Director Hwa-ung Lee. Pleased to meet you all. Thank you all for joining the panel discussion. Well, let me briefly introduce how we are going to run this panel discussion. First of all, the viewers or participants heard the current status and development progress in other nations, several cases we had, but among them, let me briefly summarize the key points. And then we will have about 20 minutes of a panel discussion, so each will have some time to share your comments and opinions. Then, for about 20 minutes, we will have an open discussion amongst the panelists on the possible issues. And for the last 10 or 20 minutes, we have participants joining the symposium via YouTube. So if there are any questions, interested questions, we will take some of them and answer to those questions. All right, then, first of all, from CURET, Institute head Mr. Huang introduced with a presentation the current status of the high-level radioactive waste management R&D status, followed by foreign cases, in particular in Amresa from Spain. They are putting a lot of efforts in developing centralized repository. And every 5 years, they are developing plans, and they are now having 8th plan, and roughly 40 billion won that they are putting budget to that end. And in the Switzerland, they are going to select a final repository, and by 2024, they also have a short-term R&D development plan. They have long-term and short-term R&D plans. And in particular, by 2024, regarding site selection, they have a lot of projects and safety cases and how to validate integrity of the spent nuclear fuel and the possible impacts from the expansion of the icebergs, glaciers. And based on those activities, they will apply for the licenses and start operation of the repository. And third, in Finland, as you well know, they are currently working on building a deep geologic repository. Therefore, the R&D, almost all of them are completed, required for licensing. So obviously, they will move on to the next step of R&D activities for the closure of the facility. And we also heard the cases and technologies from SNL in the United States. There is no clear, advancements or progress, but together with the campaigns led by the Energy Department and based on the various host rocks, including salt rock, that they are studying and conducting analysis. And what we are interested is that they have 10 host rocks, crystalline, salt, and others as well. And what's interesting is that will they be really able to dispose the dual-purpose casks? And last but not least, there were some projects related to knowledge management. In Sweden, as you all know, the licensing is on hold, but I believe it will soon make progress. And in 2021, I believe that they will acquire the construction license. So those were a brief summary of the foreign cases and status from the presentations. So as shown in those successful nations, they have a really systematic plans and they accomplished, the research results. Maybe that should be the starting point for us as well. Okay, let me wrap up the summary of the presentations from abroad. Let me move on to hearing the opinions from each panel, roughly 5 minutes each. Please try to keep the time, and then we will have a free discussion first. Regarding spent nuclear fuel management, to Mr. Huang from CURET, I'd like to ask for your comment or opinion briefly for 5 minutes. In your presentation, yes, there are 5-year plans, quite large scale. You also introduced, other projects as well. So it would be nice if you elaborate more on the connection between these projects to help a better understanding of the participants. Thank you. Yeah, first of all, on behalf of the management of the CURET and staff, I'd like to thank everyone for joining the symposium, in particular the panelists for the panel discussion out of your busy schedule. in the beginning of the symposium, as I described before, well, you already know all the challenges we have, the projects, amongst the various government agencies, and mainly led by the Ministry of Industry and Energy. There are other projects for management, safety, validation, and feasibility, and there are sub projects and tasks. So it will take roughly 5 years. So jointly, for feasibility studies and projects with other government agencies, first of all, to develop the dry storage technologies and how to validate the safety of the deep repository and related technologies. So the background of these two projects and the final outcomes of the project, it is clearly divided. The outcomes of the technology development, how to apply them to enhance the applicability of these technologies in some cases. Yes, of course, the outcomes must be, closely related to practical implementation and the concept design and the development of safety validation and the joint feasibility studies and the spent nuclear fuel, the dry storage, safety demonstration technologies. All will be combined together and implemented. And second of all, and how to assess the safety amongst related agencies, government agencies. It will be also applied for comprehensive technology development and waste management plan. So next year, these projects will be started, but it is already announced, on the internet. So I think next year, these two projects will embark in parallel. But at court, there is another agency in charge of management and validation. We will come up with a more systematic framework so that these projects can proceed more smoothly. And based on these projects, the element technologies and roadmap for these projects, we will have continuous dialogue with the relevant bodies. And this is a brief summary of the feasibility and other related, government projects.
Well, thank you very much. And for the audience online, I want to mention some of the importance of this project. By 2022, the SNF management and technology development were carried out by the main ministry who is responsible for that. But by 2022, the related ministry will jointly develop the technology for SNF management and will carry out the project. So with that purpose, we are going to carry out. So in our nuclear energy industry, I believe that the first of the history that we will launch the joint project. So this pan-ministerial level of the project is very huge, but this will be implemented in a short period of time. And we did not have a full consultation, and many parts will be carried out by the Nuclear Energy Commission. So for that, I would like to ask Head Ko Jung-hee of CARI for detailed information. Thank you. This is Ko Jung-hee. As you heard, the SNF disposal and management and safety-related technology will be pursued as a project that will be jointly carried by the related ministry. for the safe management of the SNF to realize a safe environment society for the public. We have a goal to carry out this project, and that is the goal. When it comes to the MSICT for the safe management of a SNF throughout all the life cycle, they will carry out the basic science, and also the approval authority will carry out the demonstration approval, and deep geological disposal technologies will be reviewed and developed. So when you see the major R&D, the content for the R&D first, for the long-term storage of the SNF, the storage system and demonstration system will be developed. Second, for the management of the SNF and the required performance, technology, and also coming up with a material data needed. Last, for disposal facility, the core basics related technologies should be developed. So the storage and also disposal must be differently viewed. In order to enhance the safety, we need to focus on the development of the storage safety system. So for the SNF, the storage and also radiation effect will be analyzed to come up with the appropriate method for the testing. And also the experiential and also demonstration and also the comprehensive safety plan will be used for us to develop the world level evaluation on the performance, and from the natural environment for this disposal to be naturally degraded, we are going to make best efforts to conduct analysis on the geology. For the demonstration, we're going to build a demonstration technology, and long-term integrated test should be developed. And for the long-term scenario for the geology, we need to come up with a performance technology, and if the evolution of the disposal system, we need to develop the related items behavioral testing method. As we could not have the deep and KR2 system will be used to come up with a base storage system, and also some technology development will require the international collaboration. So predicting the damage of the structure of the storage, and also the demonstration and model assessment and verification requires the US, Finland, Swiss, Czech, and other OECD NEAs should be collaborated. So from this project, what could be the KPI for the MSICT is to come up with a document for the report of master report, and also we secure the TAR, and also to bring about a world-class technology method. So the design and approval of the interim storage will be laid out, and also for the safety of the disposal facility, we are trying to use for the demonstration. And for the first time in this industry, this is jointly carried out by the ministry. So now I hope this plan be successful, and I will support as well. For this project to develop all the necessary methods and the tools for the demonstration of the URL, and hope we can produce the success outcome to restore the nuclear power energy interest. Thank you.
Well, now, if you look at the different rock types, host rocks, and for long-term, mid and long-term management and plans, the SNF, after, it will be under the management of the CORAD, but it does not mean that the nuclear power plant has no role to play. So obviously, nuclear power plants will hand over the SNF to CORAD. So it is really important to keep really good records of the use record of SNF and after storage, and before it is ready for the disposal. There should be a good set of the data and records from the beginning to the end. And so far as you all know, in each, entity independently, they, handled records. So I think it should be integrated. So now we have a panelist from KHNP and nuclear power operators. So in this concept, to standardize the, the DSNF record keeping, tracing, I'd like to ask for your, comment, please. Okay, once again, hello, my name is Gapal Lee from the Central Research Institute. I'm a chief researcher under KHNP, and for regarding SNF, the starting point of management is, I believe, KHNP. And KHNP, as an operator of nuclear power, they generate a lot of, byproducts. So as a generator of these, SNF and byproducts, we should be responsible for safe, handover and treatment of such a radioactive waste. And in addition, in KHNP, we are trying to standardize the records and information of SNF, and I believe in other institutes and entities, they also have come up with a database systems for their own, develop their own systems, and already keeping a really good database sets. And first of all, the history record of SNF from manufacturing to disposal in each entity. You must have decent sets of management data, but to manufacture the nuclear fuels, that's KNF, they have, I believe that they are managing the data on, designing and manufacturing, and the volume, weight of heavy metal and isotope and others are all in their database, and such information is provided to the nuclear operator KHNP, and then KHNP, upon receipt of such information in the nuclear reactor, how these are, respond, and as the fuel burns, there are, combustions. So related records are also kept and managed in good manner. So mostly they are, generated in the core. So the core history and combustion rate and the radionuclide inventory and other important factors are the ones we are keeping records. And in addition, for SNF, at each nuclear power plant, we keep them to reduce the energy of the spent nuclear fuel in our spent nuclear fuel storage pool. In our storage, of course, there may be some deformation of SNF, and we are managing them as well. And for temporary storage, well, there is no clear policy yet determined by the central government, but using the temporary, storage facility, we are storing them in dry condition. and the related policies are now under review. So I cannot give a clear answer or comment here, but we have certainly dry storage facilities. So these temporarily stored spent nuclear fuel will be transported to other facilities once, the intermediate level waste storage facilities become available. So for a long-term period, over hundreds of years, these SNF will be stored. But at each stage, those track records kept in each entity, it is a vast amount of a database and information. So all the related, entities, collaboration among them related to these track records should be, I believe, flexibly, exchanged. And we are trying to build a system for that. But what we want is not a comprehensive system. What we want is to standardize the, the independent systems run now by respective entity. So this is, I believe, the way we should move forward. And once it's done, between the manufacturer, the nuclear power operator, and disposal and waste treatment entities, which is correct. I think there are four main players, so there will be really good, flow of information, and we will continue to do our good work in terms of research. Thank you very much.
So now I would like to hand over a microphone to Mr. Lee Hwa-eun, but before that I'm going to mention that as a commercializing organization, how the R&D should be going forward. So could you mention about the direction of R&D policy and respective technology? And this is Lee Hwa-eun. Before again, due to the COVID-19, the countries around the world are suffering, but amid this situation, it's fortunate and meaningful that we have this opportunity to discuss on this matter. From 2009, for the radioactive waste management safety and to ensure safety of that, we have launched a project, and about 17 million won has been invested, and also deep red waste management disposal and also nuclear energy securing technologies and other relevant technologies and knowledges are being accumulated. I think so far the policies managing SNF has seen many changes when it comes to the outcome, and producing R&D had a lot of uncertainty. So rather than the large-scale project, a small-scale and basic researches have been carried out. That is the limitation, admittedly saying. But for the management of SNF, the public attention is growing, and also the commissioning of the nuclear power plant and the changes of the environment must be followed by the implementation of technology to support this SNF management and storage system. As CEO Hwang mentioned, with the collaboration of the ICT and NSSC and MOTI, we have planned a new project, and these two projects will begin from next year. By linking the two outcomes, all relevant technologies can be secured to launch a geological deep disposal system demonstration testing. And I believe that commercial part also must be focused. So for the mid and long term plan, are going to provide the method for the demonstration and the validation of the SNF management system. And we're going to support this data. And also with this data, we're going to support the plan and policies. So in this background, I'm going to share with you my opinion. Already the advanced countries have been producing the safety evaluations and outcomes. However, our success rate is 75% compared to them. The gap between the technology and also objective and safety should be ensured, so we need to pursue an open R&D. As we are latecomer, the professionals in this area is lacking as well. So related to technology, not only that, the professionals from the social sciences are needed. So we need to have a qualified professionals, not only the engineering, civil engineering, and the geology. We need to foster the talents in this area. By fostering the companies and by fostering the private sectors with the professionals, we can produce an outcome from the project going forward. The rat waste management technology has some public characteristics, so rather than commercial side, it has focused on the technology-related areas. And it is a project that it has a high uncertainty in terms of marketability, so the connected ecosystems are lacking as well. And some parts are inaccessible by the public, so there is a limitation in terms of the R&D, technological development, and also as this is a limited market, so SMEs and other companies are having difficulties to have an entry. And even if they are in this area, it is still really difficult for them to come up with a tangible outcome. So from the initial phase, we have to consider the demand and also the approval procedures, and also by the long-term technology exchanges, we could enable to produce the outcomes and also nurture talents, and we can build the industrial infrastructures to create a good ecosystem. Last but not least, from our company with the KHNP and the CORAD for the successful implementation of the project and to nurture the qualified profession, we need to properly cooperate in timely manner and also collaborate with international agencies as well. Thank you. Thank you.
Thank you very much. Well, now we are 5 to 7 minutes running behind schedule, so what I expect is that to wrap up this panel discussion by 6 o'clock. So I believe the audience watching the symposium will probably have a more difficult time sitting in. So we have 4 panelists shared their opinions. And now to the audience, if you have any questions regarding the comments, please put them on the chat bar. Then we will take some of them and answer. Now we have 5 minutes each for the panelists. So in general, starting from next year, it doesn't really matter whether it's preliminary or just non-preliminary to the feasibility projects. I think it is really important that we move ahead, and the Ministry of Science, MSIT, they have their own agendas, and for technology developments, there will be a certain time frame as well. So, and at least to the level of a pre-licensing, there are, different roles to be played, and I believe the Ministry of Trade, Industry and Energy have a bigger role to play. So I think each players should play their role, otherwise it will not work. So based on the comments we shared today, obviously we share the common ideas. We have a common goal to achieve. So that's how I interpreted the comments, and we will move on to free discussion. We have 4 panelists. And regarding their comments, there are some, issues worth we have a free discussions. Not too long, but briefly. First of all, from Mr. Hwang Lee regarding the decommissioning. Well, in the previous government, there were a lot of investment in terms of budget and manpower, but for SNF management and disposal, in particular for manpower, we did not put much interest and effort. You highlighted that. So regarding that, the audience would like to know if there's some ideas or directions or plans. So anyone can answer. Please raise your hand. Yes, Mr. Wang. Okay, yes, as you mentioned before, here, for the pre-feasibility projects, it's really, meaningful. And we have a lot of meaningful discussions today. And among the panelists, representing the leading entities in this field, we are having a really successful, workshops, not this one before. So in addition to NSSC, we had several rounds of dialogues and discussions. And back then, yes, we also talked about how to nurture, necessary human resources. So, the panelists and their organizations, together there, the research manpower, it's only about 40 researchers, experts. So in Sweden, they have 1,250, France, roughly 150. So how we are going to build up the human resources, what kind of strategies we are going to have, that's really important, I think. In particular, regarding SNF, it's not something we can plan to 3 years from now or 5 years from now. We should take a really long-term perspective. So in addition to creativity, we also have to ensure the continuity for a long-term period. So, when we lose trained and highly skilled human resources in this field in a short-term period, then we will have a serious problem. So there's no special training school to nurture human resources for that matter. So I think we should establish a kind of a specialized curriculum or courses in already existing colleges and academic institutions. So in addition, related organizations and the government may provide some scholarships or subsidies to encourage such activities. Thank you very much.
Well, this is a free discussion, so we do have a limitation of time, so please reduce your comment within 1 minute. And probably many people are considering about this project and related ministries. In December, will collect the idea. So, Mr. Koo, do you have any idea? I believe that Mr. Lee Hwa-eun mentioned a very important thing, as these jobs were siloed because they were distributed across the ministry, but taking this opportunity as an opportunity, all the multi-ministries can join their forces. Of course, we need a new talents and manpower, but existing manpowers should be used, and we have to consider that as separated. I believe that we need to have a technology exchanges. If needed, the King's members should be invited to have discussions, and also we need to have a plan to foster both the newcomers and old schools. If there's no further comment on that, then we're going to move to the next topic. When it comes to the Heta Pyheta project, and after 9 years, it's related to the storage. The base test will be finalized, the specific license will be finalized. The additional effort is very limited, and for the first time, the URL demonstrate project and the data will be submitted for this license. So for our review, in construction 5 years, and also when it comes to site selections and design, it will take about 5 years more. Then next year, the site should be decided. So this is a very pressing situation that we are faced. So the physical time takes like that. So we cannot give a answer right away, though. But do you have any comment on that? I know this is a very challenging topic. So do you have any comment on that? Mr. Huang, as a body responsible for that, you already mentioned.
As I mentioned in my presentation, well, the pre-feasibility, project, what kind of activities are we going to do? There were some discussions. Well, anyhow, to successfully select a site, in other nations who made the progress, they certainly secured enough, underground area. So we need to put more effort. But regarding site selection, for demonstrational or research purpose, URL, for research purpose URL, the location of a disposal facility, it's not related. If it is clearly, identified by law, I think, in Switzerland, they are actually utilizing these facilities for, tourism purposes. So it will give a further motivation for us to make, progress. Okay, thank you. Well, regarding research purpose URL, it is a radioactive facility, so it requires regulatory licensing from the NSSC. So I think there's a possibility that it will be well accepted by the general public. And I would like to certainly look forward to see that due to time constraint. Let me just, to sort out noteworthy issues. Okay, to Mr. Kapogli from KHMP. I think you are doing a lot of research in, in-plant storage, so on-site storage. So if you have any R&D projects to share or the direction or in general, any comments you'd like to share with us? Yes, well, for temporary storage, which is a step before, permanent or final disposal, yes, it's a really sensitive issue. So how we are going to handle the temporary storage, by large, for dry storage in KHMP, we checked validate safety, and we also conducted researches related to regulations and licensing, so that we have a better understanding on the concept of the repository and the storage containers. And another one is for SNF, storage pool. We need to secure enough, data on the radiation-related factors. Otherwise, there will be, to poor accessibility. So, while the SNF is stored in the pool, we need to secure all the necessary data. So, while the SNF is stored in the pool, we collect radiation and all the necessary characteristics-related data. Those are the key 2 points in our management. Yes, thank you very much. So such research activities, I think, should be cross-boundary, among the related entities. Okay, then, to Mr. Huang, he gave a comment on the pre-feasibility and feasibility project. So each project has their own objectives, and obviously the MOTI has their own objects. And while the Ministry of the Science and ICT have their own, objectives. The projects will start next year. So any comments to add? Yes.
For the Finland type the deep repository system is the model that we are going to develop the test. However, our land is small and there is an issue of public acceptance. So how can we ensure the safety and how can we conduct that? So we are conducting the feasibility in that way. So with this feasibility, we do carry out, and if we find out there is a feasibility, feasible and viable, then we can confirm which one is appropriate for our disposal system. And also the panelists said, as this is important venue, whether it is CORAD or the KHNP, we should cooperate because we don't have not that much talent in terms of number. So I've been working for 34 years in this institute and I developed the canister and cask, and I also had an experience in on-site. But people who are on the desk, they are fearing of the on-site. So, but if they don't challenge themselves to move forward and not develop themselves, then we can fall far behind that of the advanced nations. So at the level of that we can win the license, we can provide the data showing that we do have this kind of solution to the approval body. So in this way, I believe that we did have a great venue for the great discussion and exchange of ideas. And now we're going to move to the Q&A session.
Well, I'd like to ask those, in charge of the, the system management of the symposium to please collect the questions. Okay, we have several issues. Well, of course, in 2021, the projects to start next year, yes, the related government bodies will put heads together and following the time frame of the projects, they will work together. We have a really systematically established plans and projects, but in the past, each entity performed their own projects independently, so we lacked continuity and integrity. So, learning from our past, experiences, maybe for SNF management, technology development, should be, handled amongst all the related bodies together, not by one single organization. That should be the way. I think that is the way so that we can have a timely implementation and operation. To that end, I'd like to ask for your comments. Okay, yes. There are several R&D activities from the government. There are quite peculiar ones, and road waste management projects are one of them. And at the end of the day, from the business entities and in the market, there are companies, business entities. Of course, their goal is to generate profits, but we are not those ones. Therefore, we have some difficulties to be part of the market. So, and there are some changes in the government policy. So, and there are some limitations to that end. The collaboration among relevant bodies, I think that's the key. And in preparation of this feasibility project, we took almost 2 years. So in trying, as mentioned before, there were some, of course, ups and downs, some missing loops. Now we are making progress. So after the project is completed, based on the review results of the committee, I think it will have a really good connection and leading to good accomplishment of R&D activities. That's what we are looking forward to. So in the future, I think we will have a better collaboration as we move forward.
Well, thank you very much. And we have seen a lot of questions, and I believe that there will be a lot of questions, but cannot confirm. So if you send me the questions, then we can address them in our discussion. And I believe what you have mentioned, I do personally have some opinions to put forth. Maybe I am wrong, but while we having a public a consensus building efforts, the 90% of the people are showing the level of higher acceptance of that, but that is having a function of the administrative. So the decision, implementation, and surveillance all must be covered. And for the technology development, I believe that body should manage. I think that is reasonable. That is what I recently think. So from headquarters level, they do plan the R&D, and the organization below can carry out the plans. And I don't see any questions coming from. So now let's shift gears to other topic. And I believe Mr. Huang mentioned, and when it comes to the canister, I believe the Korea has been upgrading. So like companies like Tucson and others, some companies are developing good quality canister. So it is a government-led project, so it is difficult for the private sectors to try. So what is worrisome now is that the site selection test will start in 2021, but when it comes to disposal sites test, if the law introduced during then will start in 2022, we believe. But as you know, when it comes to geological investigation agency, they are having a poor industry ecosystem because there is no a project to have that kind of investment. So the quality, I'm sorry to say that, should be improved to the level of the international standards. But accidentally, we are having the open bidding process, but that could be a move to the limited bidding later. But the quality of the bidders can be an issue. So separate from the R&D, I believe that's an issue that has been created out of that. So I believe that you need to consider as well. So broadly speaking, this is in line with the fostering of the industry. That is the starting point. However, the interpreting data model, if it has a wrong data, then you can have the error in outcome. So you need to have a very good first step.
Okay, let me briefly check whether we have more questions from the floor. Okay, from what I see, we have one question here. The question is, in Korea, like in other nations, are we going to have a disposal URL? If so, when do you think it will happen? Well, I think there's no need to give an answer to that, but just in case, if you'd like to give some comment or answer, please do so, or we will just move on. All right, Mr. Huang. Well, the one who asked the question, let me give some comments or answer from a technical perspective. So we have a certain standard for the high-level waste management, and from the comprehensive safety validation and ensuring that we also have related standards and criteria. So that should be the first step to actually comply with those rules and regulations and standards. Yes, from the NSSC, this is a kind of a mandatory requirement. So we cannot just move ahead without following the necessary steps. So we have about 5 minutes left. We once again to thank all the panelists for joining, taking time out of their busy schedules. So before we wrap up, I'd like to ask their closing comments. Okay, to our host of the symposium, Mr. Huang or Mr. Gu.
Well, first of all, I'd like to thank the members of the Quora for preparing this valuable meaningful venue, and also many panelists opined very important messages. And while I'm here and looking back, I become a old school. But the new generation has some difficulty even getting the approval. But when it comes to the URL that you have mentioned, I wanted to give an answer. If you are not verified, then you cannot get the approval. So the basic procedures, such as the R&D, must be first carried out, and then we have to make efforts to come up with the relevant law. So in the case that there is a ASNF used discussion was held, so they said that we need to make this illegal, and we have to select the site. And in this area, we need to collaborate further. Mr. Lee.
Okay, yes, thank you for giving this, meaningful an opportunity. I'd like to thank members from Korea in KHMP. Generating nuclear power energy. Yes, inevitably we are generating, radioactive waste. So, feeling the heavy burden on our shoulder and taking full responsibility, we will do our efforts to ensure the safe management and treatment of radioactive waste. And first of all, we will thoroughly manage the tracking or history record of radioactive waste so that we do not have any, unnecessary situations due to missing information. So we will thoroughly, to manage our data. Thank you very much. Okay, Mr. Huang Lee.
Well, my comment is that as a body under the MOTE, not only the R&D, the international cooperation, and professional nurturings are there that we do focus, as you have mentioned. We have to listen to the voices coming across the society, and we have to not neglect them, and we have to live that going forward. And last but not least, I want to mention one thing. In line with the concept of the MOTE, and as I mentioned that there is no such an industry as of now in Korea, but ultimately I believe that this red waste area as an industry could be fostered. So we need to achieve this a picture. Thank you. Thank you.
Okay, Mr. Wang. Yes, well, the pre-feasibility projects to be conducted by all the relevant government bodies, it's really meaningful that we have this project ready to embark next year. So I sincerely hope that we have a really successful outcome. And apart from the technology development related to SNF, we have a lot of, issues, pending issues in all the, entities. So we should take a common, actions and response. And last but not least, the chair and the panelists, I'd like to thank for taking your valuable time out of busy schedule. Thank you very much. Okay, let me wrap up the panel discussion with a final comment. Well, the management of SNF and disposal of it, looking at the successful cases of other nations, at the end of the day, it depends on how we have a really well-established systems. So we have, administrative license from NSSC, but the social license, it's given from the general public, from the society. And when we develop, related legislations and laws and regulations, certainly a veto from the, local residents will play a quite big role. So, government alone cannot succeed, and one single organization cannot succeed. So obviously, we have an increasing interest from the general public and from the media, and we have more and more real-time dialogues between the general public and the media on the key social issues. So we need certainly great support from the general public. We need to build a trust with the general public. So that's something what we need. And for a long time, I'd like to thank everyone for joining the symposium, to the panelists, and also to audience watching the symposium via YouTube. Thank you very much.
Well, thank you very much, Mr. Kim. And that was the topic that we needed to discuss. But despite a short period of time, we had a rather in-depth discussion. So we could have a very useful information, like what area that the government and academic areas should support and collaborate. So we could have a broader understanding. And also, I hope this would be a hopeful message to the public as well. And for the radioactive waste management and R&D related R&Ds should be developed according to the desirable directions, I hope. So I would like to thank all the online audiences, and also I'd like to give many thanks for those who stayed with us till now. So with that, we're going to conclude the session. Now I would like to declare the end of the 7th International Symposium on Safety Improvement and Stakeholder Confidence in Radioactive Waste Management. So let's see you next symposium.